Welcome back to the Aviation-Rcnoob podcast. You found us. My name is Joe.
And I'm Matt.
We're here to be with you along your journey and to share our experiences in RC aviation. If you have any questions, thoughts, or want to share a flight story, hit us up at aviationrcnoob@gmail.com. Now, buckle in. Let's take off.
Welcome back, everybody, to another episode of the Aviation RC Noob podcast. I am your host, Matt Allen, and Joe had to be other places tonight, and I asked Richard Joy to join us again. If you don't recall, Richard, say hello. He's been with us a handful of times to talk about various subjects, but one of them that he's passionate about, we'll have him talk about today. Welcome, Richard.
Thanks for having me on.
Yeah. You're always welcome. So Richard has dove deep into the realms of 3D printing, and that he's an RC enthusiast. He has built tons of planes like we all have, because the correct number of planes is n+1, which is the amount of planes you have plus another one. How many you have. And he had either, well, you can tell us your story when you get to it. But every time I have a question about 3D printing, or in our Discord, somebody has a question about 3D printing, Richard is the person who almost always has a quick, intelligent, and helpful response. And so I really appreciate you being part of our community in general, but as well as just, I feel like I can call you a good friend. But when I think of 3D printing, and I think, who's got experience enough to kind of help me solve the silly little problem or whatever I've got, or at least knows what's going on now with regard to what you can do with aviation and 3D printing, RC aviation. I think, let me talk to Richard. So I'm glad you could come on the show tonight. So how we do our show typically. So usually we take a couple minutes. We talk about what we've been doing in the aviation RC hobby. Then we kind of hit a history, but today I'm going to forgo the history. We'll tackle that next time, but I'm sure it'll be involved. And then we'll get into the main topic. Richard, what are we going to talk about specifically today?
Well, you want to talk about what we've done in the last few weeks in the hobby?
Yeah, that's right. I did say that, didn't I?
Yeah. Okay.
Yeah.
Well,
so tell us what you've been up to. Have you been flying anything?
I flew this morning.
Oh, nice. Okay. So you were the one, you've been working on kind of on and off on float planes in the last year, it seemed, right?
Yeah. We had a bit of a problem there. The local lake decided that we're not technically allowed to fly in the lake because we fly more than 5 miles an hour.
You fly more than 5 miles an hour on the lake for about
there's
20 feet,
exactly.
And then off you go, right?
Exactly. There's a.
Are they going to stop all the birds too?
It's crazy. It's there's this. I mean, we flew there pretty much the same place at the lake for the whole of last year.
Okay.
And no one complained. The public came by.
They seem to be overjoyed every time they saw you guys. Always willing to
exactly,
help.
If
you had a lost plane, like a plane out in the lake, they're like, "Oh, I'll get it." You're like,
yeah. We had this lady that flew, that swam out and rescued my FT cub, and almost drowned, I think. But she, the kids liked it. They were watching the planes fly, and then there was just a couple of people that I guess people from the park said no, we're not allowed to fly because that particular area it does actually have a 5 mile an hour speed limit. But this is for boats and paddle boards and stuff,
Yeah,
and not planes. I mean, obviously once you're in the air, they don't have any.
All the rules are off, right? You can do what the AMA and The
Yeah,
FAA allows at that point.
exactly. It's all up to the FAA by that time. But so one of the things I did think about is making a VTOL plane that would
Right.
fly off the lake. But it's maybe not. But anyway, we're trying different places. There are places where we can fly, where the speed limit is not 5 miles an hour. I do plan on meeting up some guys tomorrow to fly at the lake. The interesting thing is that the lake here, there's been a big concern about, I think it's called golden mussels. There's
an invasion, as it were.
An invasion of several lakes in this area that has golden mussels. So they pretty much banned boats to launch into the lake. It's the reservoir, but and so there's been like a 1-month quarantine for these boats. And so tomorrow we should be okay because the quarantine will finish I think in May 14th. So we're free to fly off the boat ramps tomorrow, but probably after that they're going to be pretty busy throughout the summer. So basically we moved from a very sort of recreational area, where we got banned from, to a more, where they basically do the boat ramp area, and that's going to be perhaps a little bit more of a challenge to fly off. But
it's just what you were looking for, right?
Yeah, just we'll have to see how it goes. But yeah, it's great fun. I think we did a podcast on this a while back.
Matter of fact, I was trying to look up what episode was the last one we had you with us. But we'll find out, and I'll make sure to link it in. I'll link it in the description down below the YouTube video. Speaking of, if you didn't know, we'll call it simulcast. I don't know if that's what you want to call that, but when we release our episodes, we also release them to YouTube. So depending on what platform you enjoy listening to us on, you can listen to us in YouTube. There's if we're having an interview like this, where we're talking to a guest, and it's not just Joe and our ugly mugs. We try to spare you the pain, and we just do an audio. But yeah, we're gonna post this one as video. I know Richard has a small, he put together a slideshow with some pictures and things like that. So I'm looking forward to kind of seeing what we have there. So I sidetracked you. Started talking about the lake. What did you end up doing?
So today I flew my latest. Even though I'm very passionate about 3D printed planes, I still haven't left building foam board planes. So I really still like to build flight test type planes. And my latest build on the flight test side was the FT Super Scout XL that they came out several weeks ago with.
Yeah, what do you think of that? How's that fly?
It's so slow. It's really slow. And so what I did is I built that. It was kind of like a bit of a rush build, but I built it. We had at our club we have this yearly everything electric event. And so the nice thing about the new Super Scout XL is it's got a bomb bay. And I purchased a bunch of these like little parachute men, and I put those into the bomb bay, and I dropped those over the runway. Nice. And actually they didn't end up on the runway. They actually ended up miles and miles away because the wind basically just took them.
How high did you release them?
I don't know, maybe about 100 feet. It wasn't that high. But there was
it was a pretty stiff breeze.
Yeah, there was a pretty stiff breeze, and it took them a fair bit. But it was it was good fun. It was
of course.
And I think I mentioned this before. We have there's a sub part of our club that's for 8 to 18-year-olds.
Yeah,
so it's
exciting.
It's to encourage obviously younger people to join the club, and they get some privileges like a very preferential rate for the club, and a lot of events. They get free lunch and all this sort of stuff. So
Yeah.
it was kind of more of an event for them. But I even I'm one of the older guys, I try to participate in that event.
Are you kidding me? You'd be one of the young guys with me over in my club.
Yeah. Well, next month I'm going to be one of the old guys. So, so that was good. That was I don't know if you know the history of the Super Scout, the FT Super Scout. I think it was Dan Spons that did the first iteration of that.
Yeah, I think I remember that, right? And he just he did made it look like the Red Baron or whatever it was, and it's a pretty common model, right? Like it's very similar to a stick, right? It's
well, it's basically it's the small Scout. I mean, there's actually a mini Scout. The FT has a mini Scout, and they have a regular Scout. And I built several regular Scouts, and they fly great. But this was a Super Scout, and I think they had it. There was I think it might have been Flight Fest 22 that they had I think it was like a World War One event.
Oh, when they had they made the micro Scouts or whatever, and everybody had their own livery.
Yeah, and I think I think it was actually everybody was it was going to be like a 1/8 scale or something like a 1/6 scale, And so the idea was to design your own, design your own 1/6 World War One plane. But a lot of people obviously didn't have time to do that. So Dan came up with this the soup. He just scaled up upscaled the Scout, and so made those plans available. But then actually Josh and those guys, they basically made it into a kit. So they did make some changes to that. I was kind of in that transition. So I built that first version, which was kind of like a hybrid of Dan's design and the modifications. But the problem with it is it had a fixed wing. So and this thing is really large.
Yeah, so it's like 60 inches or 45. It's in the 40 to 50 or 40 to 60 inch range.
It's almost 60 inches, because it uses up pretty much a whole street. Each half of the wing is like
so not having it detachable means you're taking up a seat definitely. If not all of your trunk.
So the first version I built was really I had to modify it to make the wing removable just to fit in the car, and I think that was its downfall because it basically just took off and just went into the ground. It didn't last. It lasted about 15 seconds. But they made some huge changes to this new version that they've now called the Super Scout XL.
Right.
So there's a number of changes. One is that the wing is removable. And it's a very, very interesting design, really good design, very solid. You basically use screws to anchor the wing into the fuselage, and then the other thing is the battery goes in from the top. They have this really nice.
Right. Yep. Like a top hatch that comes off.
Yeah, the top hatch comes off. And so it's a real. It was a pleasure to build and a pleasure to fly. Very, 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 really. I didn't see any real problems with it at all. I did have a little bit of problem building in the build, and I have a build video, not build video, but a build log on Flight Test Forum. It's a bit tricky. The hatch part, the bendy bit is a bit of a challenge, but apart from that, it's pretty easy to build. I think it takes about 8 sheets of foam board. I ended up using 10 because I was
going to say it sounds about right.
Yeah, but no, that's good. And then this morning I also took out the storage, the FT storage.
Oh yeah.
which I have not.
it's funny because I have people have mixed reviews on that one. Like my experience for the first couple times before I crashed it too much, was excellent. It was a great slow flyer. I could deploy flaps and like really have it go even slower. And I'm like, I don't think that's safe, but
Yeah,
it
you
was
don't need
fun.
flap. You don't need flaps with the storage. It's like,
No, no,
you
that's what I
know.
learned. Like, what am I doing? Yeah, yeah.
Yeah, no, that's nice. Actually a nice bit. I mean, the only challenging part of that build is the landing gear. There's a lot of wire bending, and you have to kind of get it, in the right angles and stuff. But no, I just picked out. I really was hoping to maiden a 3D printed plane this morning,
Hmm.
which is the Eclipse on Model B XL. They also do XLs as well.
Okay.
That's about a 60-inch wingspan, which is pretty large for a 3D printed plane. And
Right.
it's a bush plane. And I've had it built for ages. And
Okay.
I
Yeah.
get to about 90 odd percent, and then I'll do a little bit more percent, and then I'll do and it was not quite ready to fly this morning. But the interesting thing about that build, and it's actually over here. I know you can
Yeah. I
see
see
that
it behind you
there.
there. Right.
Yeah. Is it has floats, so it's not only
Hmm.
a 3D printed push plane with 3D printed tires, big old fat tires. It's also got some interesting, pretty large floats, which include actually a water rudder. So
Yeah. I see that. Look at that.
the water rudder has a kind of you have a piece of fishing wire going up to the actual rudder, and then that you really need that. I found that with float flying, in order to maneuver in the water, you really need to have
Yeah. Maneuver
a some
well. Yeah.
a water rudder. You can't really, especially with if you've got a twin engine plane, fine, you can use differential thrust. That's not a thing. I built the Sea Duck last year, and that went really well because you've got the differential thrust. So that maneuvers pretty well in the water. But if you've got a single engine plane to go in the water, you really need a water rudder to maneuver about.
Yeah. Yeah. What is the? Maybe we can leave this for later, and
Hmm.
we can earmark it. Let's talk about floats, 3D printed floats, later when we talk about considerations you need to do when you're making different parts of a plane, like material and all that kind of stuff. But I'm curious to see what Eclipse On recommends to prepare the floats to be waterworthy,
Hmm.
because a lot of people, I remember when I was printing the submarine, the 3D printed submarine. One
Oh
of
yeah.
the conversations about that is like, hey, PLA, the printing back then wasn't as spectacular as it is now, right? When you did it wrong, there were gaps in your layers, and and then you're like,
Mhm.
do I print it again and take another 18 hours, or this is back in the early days. And one of the recommendations is just epoxy coat it. Just get a certain kind of epoxy, thin it out a little bit, and then just brush it on, and like do a coat or two of that, and do it inside and out, because
Yeah.
when you get water inside, it'll get sucked in all the corners of
Yeah.
your print, and it'll never come out.
I'm,
So
yeah, I must admit, the only other 3D printed plane that I've actually built and flown is the 3D lab print Piper J3 Cub.
it's just
And that,
similar to what you got there then.
well, it's a much smaller plane,
Right.
and it did float okay. I did paint the floats, but that's the only thing I did to seal them. And I'm hoping that, I've painted these floats. So generally, what I've understood is that as long as as long as you obviously make sure that you've glued the sections together, because they will, especially if they're large floats.
Uh-huh.
As long as you spray paint them, give a decent, few coats of spray paint, that usually does a good seal.
Okay.
You know,
Yeah,
there's other things like Flexi Seal, and there's another option, but that adds a lot of weight. Flexi Seal tends to be a bit heavy,
yeah.
so yeah.
Yeah, with the with the RC submarine,
Mhm.
weight's not an issue.
Yeah,
Like
exactly. Yeah.
weight is not the issue. You're usually adding like many pounds of weight
Mm.
to get that to float to
Mm.
perform properly. But yeah, with the airplanes, it's a different story. Well, cool.
Mhm.
Okay. Um, so is that summarize kind of what you? I mean, that's a lot. That's a lot of flying lately. That sounds pretty good.
Yeah,
I'm
yeah,
all
yeah,
about
yeah.
it. Kind of jealous.
Yeah, yeah. So, well, now though, I mean, the last 2 weeks has been a bit windy. So,
Okay.
but today was today was real calm. Like 2-3 mile an hour winds, so it's really, really ideal. The In terms of building, prior to the Scout, I actually did build the Horton, the Eclipse on Horton 229,
Oh
but
wow, yeah. A lot of people
I
love
haven't,
that.
yeah, I haven't actually flown it. It's still sort of in the midst of construction.
Okay.
Interesting plane. It's got twin EDF, 50 millimeter EDFs.
Right. Yeah.
It's interesting. It's a wing, which was designed. The full scale version was designed back in 45, so it's not
Yeah.
new.
No, it's not new,
Um,
but it was new at the time because it was working hard. All of the aircraft manufacturers at the time, Russian, German, and American, were trying to find the magic formula to get rid of the rudder
yeah,
or to get rid of the fuselage, the empennage, pretty much, because that produced 20-30% of drag. You could go so much faster if you didn't have that drag, right? At least that's the theory, right? That's what they were all aiming for. So they're trying to figure out how to do that, and the Hortons were just so darn close.
well, actually,
Yeah.
what
They
what
had
kind of
success,
yeah.
but they were almost close to finding the pure, we'll call it the purest, right?
Mm. Yeah, I mean, there's a whole history if you look at the Horton brothers and the way that they designed. In fact, they designed uh, maybe not RC, but like free flight gliders, during the
Mm-hmm.
time, and then they were moved to for full scale, and then eventually, and they were kind of late in the war when World War II.
Yep.
But that could have been a game changer if fortunately it wasn't. But
Right.
that thing I think was probably a 600 mile an hour plane. Where like the Spitfire was only 300, 300 and something,
Yep.
or maybe
Yeah,
400 max.
350. Yeah, they
Yeah,
were,
yeah, yeah.
which was, for its technology, was pretty darn fast.
Oh yeah,
I
yeah.
mean,
No,
most of the planes were coming close to, we'll call it the optimal sub Mach number,
mhm.
right? Like they were kind of skirting up near, and they realized like it's so hard to get the propulsion methods just weren't enough to kind of get all the way
Mm.
there.
Yep.
And then once the jet engine came, it was like, whoa, hold on.
Yeah. No,
What
it's
we just
I
changed
might
this.
yeah. Well, a friend of mine, he's like a aviation historian,
Oh,
and
great.
he every time I come up with I tell him, hey Tom, I'm building this plane now. He comes up with a pile of books, and
Oh,
it's all
awesome.
the history, all the history, which is really, really interesting. Yeah, so that's one of my many planes that I have to eventually get finished and flown.
Nice.
Hopefully this sometime this summer. And
Well,
and
that
then
sounds
just and
good.
then just the one prior to that was the Eclipse on Model CV2. I ended up doing it. One of the things that Eclipse on, which is one of the 3D
Hmm.
3D printed plane companies, what they do is they ask for volunteers to do beta testing,
Yes.
and they have a Facebook group. So if you follow the Facebook group, every so often they're coming out with a new model. They'll say, we're looking for beta testers, and it's a bit of a commitment because you've got to. They give you like three
Yeah,
to
because
four weeks.
they're trying to test their products
Yeah.
with
Mhm.
so that they can get it right, and once so that way they can release it and know it'll be successful and it'll be promoted naturally, right? you know,
Yep.
RC flyers, RC builders tend to be somewhat fickle about the things they like and the things they don't. So if you haven't really tested it with your, with your audience much. It's a 50-50 shot. It's going to be received well, right? So by having
no,
somebody like
yeah.
you who can really sit down with it and build it and kind of give them, hey, this is what I encountered. This is what we liked and what we didn't.
Well, yeah, and in fact, that was my second beta test. I tested their Model X about a year or so ago. I've been tempted to do all the beta testing, but like I said, it's a bit of a commitment because you've pretty much, with that 4 weeks of beta testing, I mean, basically what they'll do is they'll give you the files.
Right.
So basically you have to convince them you've printed some of their planes in the past, and you know what kind of
Yeah.
you have
what you're in for.
Yeah.
Yeah.
And I mean they can check to see whether you purchased their planes. So
right.
I'm
looking at the Model X. That's a good looking bird.
Oh yeah, the Model X is still hanging on the wall next door.
Good.
I have
need to get flying.
I never flew it. I mean, part of the beta testing is that you've got to print it, you got to assemble it, and you got to fly it, and you got to give feedback. But that one never got off the ground. In fact, I think they only gave us 3 weeks, and it was a big plane. It's like a 2-meter wingspan. It's
it's a good size. It reminds me of it's now deeply tucked into the corner, but it's the Vampire. It reminds me very much of the Vampire.
Yeah,
but like a V-tail.
Yes, it's an inverted V-tail.
Yeah.
Yes, it's an inverted
that's
V-tail.
actually a natural way to create. If you're going to roll, it creates a natural kick out of the tail too.
Okay.
So to be coordinated. So the A tail is a more natural, safer way to move. But a lot of people don't like A tails. I don't know that it looks cooler as a V tail, right? So, but V tails kind of have to battle adverse yaw a lot more than A tails. A tails naturally combat the.
I mean, it's an interesting design. I mean, basically what they do, the process is that if you do sign up, you get accepted. What they'll do is they basically invite you to a private Facebook group.
Mm-hmm.
So there's one guy that represents Clipson, and he coordinates the stuff. And then they may give you not all the files initially. They just maybe give you, say, the wing for you to print. Because it typically takes you at least a week to print the files. So in that 3 to 4 weeks, you want 1 week of printing, 1 week of assembly, and then you really in the third week you want to be flying because you don't know what the weather's going to be like. You've got to schedule time at the field and stuff like that.
Hey, look. With the Build Droid contest, don't we know it?
Yes, exactly. Yeah.
You try to build and fly 4 planes in 4 weeks. One of the hardest things I think a lot of people are, if they do find the time to build a plane, a lot of the complaints are like, I can't get out and fly. It's just terrible. This time of year is terrible. It's just not good weather, and I'm out of time.
Well, we typically, here in California, we don't, the weather's pretty good, but it still can be really windy. That's why we have wildfires. So
exactly.
So it's and in the last couple of weeks, it's been far too windy to fly. Not constant wind, but that gusty wind. That's going to be the worst.
Yeah, and the gusty wind. Full scale. Oof. Yeah, it's bad no matter what, right? So I hear you. But
the Model C was the reason why I ended up doing the beta testing for the Model C is that, and this was so basically Clipson is kind of like, I think they're going through their old inventory of planes, and they're revamping some of the models. Okay, so they're making version 2s of the models.
Because things have gotten a little bit, I don't know, easier and smarter. That's actually part of why we're talking today.
Right.
Is to talk about some of those changes that have made 3D printing a far more approachable affair than it used to be.
Yeah. Basically, there's some more techniques that they're using in basically part of their design that makes it easier to print the parts. And so because I'd already built the Model C version 1, and that was an interesting maiden flight. Well, actually, the second flight, the wings just folded in midair because that plane did not have carbon fiber tubing for a spar, and apparently several people had the same problem. So, but the version 2 does have a cable, does have carbon fiber spars. It's kind of pretty much you need it for 3D printed planes to have carbon fiber tubing for a spar. So I figured, well, exactly, why, since I've already built the Model C V1, I'll volunteer to do the Model V2, and that worked. I did actually fly it. I did give feedback and stuff, so that went pretty well. And I have the plane and everything. And basically, your reward for doing the beta testing is they will give you the free, once they release the files to the public, then they'll give you those for free. But I mean, you still got to provide the filament. You still have to provide, all the electronics and everything. But they're really good. I mean, I spoke to the guy and I said, look, I already have the V1, which means I'm entitled to the V2 because if you purchase their files on a version 1, they'll automatically give you the V2. And so that's how I got the Horton 229 because I said, can I have another plane? Can I have another free plane? And so they said, yeah, just tell me what you want.
That's pretty awesome. That they
and
were happy
and I'm actually, the choice of the 229 was kind of what you did with your episode with Alan, not Alan, Al Boas, because he mentioned about with the Prandtl wing, and he mentioned about there were some similarities between, the Prandtl and the Horton 229. I mean, the fact that it was a wing design. So
that's what they were taught. That's a big piece of what he was talking about, is that there were two major designers that were really chasing the solution to an efficient tailless aircraft that would fly without a rudder.
Yeah.
And it had been elusive, and the Horton brothers were coming at it in one way, and I'm blanking on the other group that was tackling the same problem, but I think I want to say it was like Boeing, but I think it was somebody in particular. And they had like crossed paths and never really fully talked, but they were close and they were almost there. Prandtl had shown up too, and they almost all sat together and talked this problem through and really considered the concerns that they had about it or the problems they were having. They might have actually come to it earlier, but alas, ships in the night, I guess.
Yeah.
But yeah, Hortons were, and they, the big thing with the swept wing is you have a lot of, we'll call it longitudinal air movement.
Mm-hmm.
And that leads to very abrupt tip stalls and very low. I'm literally watching a guy. I think it's a Klingspar flying wing project. It's a guy in California. Must have been 8-9 years ago. I think he actually helped build the glider that they brought out as part of the Prandtl test. I think he either helped with that or he was talking about it with them for sure. And anyway, he's talking about how the way the control surfaces are at the end of a flying wing, if they're just like a thin ribbon, the air hits it and slides straight along. And what ends up being is you lose the lift. You're no longer creating any lift or any, and the forces are minimal, or you're not actually creating a resistive force anymore. And so what happens is you have very low controllability. Whereas if you're out and it's perpendicular, but they're all swept, so it's kind of weird shaped, it's almost like a reverse taper surface to the tapered and swept wing. you end up actually getting far more control because the wind doesn't slide off the edges. It slides across the wing surface, creating more pressure. And he has a whole test on it and all. Again, I was watching it the other day. I was like, "Whoa, this is awesome."
Mhm. Yeah, no, well, no,
Things to
it's a
consider.
yeah, it's fascinating, area of aviation design.
Yeah, it is.
Um,
I
but
guess being
yeah,
where you
mm,
guys are or where he is, I don't know where he is,
mm,
but it's near a beach where they hang glide often. And so he just brings a wing out, and rather than like
mm,
fly the wing, he just holds it in place with the tufts on it, and he watches what happens because the wind's whipping across the dune at 30, 40, 50 miles an hour, which is flying speed for the hang gliders, which is one of what his project is. So
mm,
he's just, I'm like, oh, that must be nice. You don't have to
mm,
bring it to wind tunnel. You just sort of go outside,
mm, mm.
take a look. Anyway, um,
I think it was was it Northrop Grumman was
well,
also working on? Yeah,
yeah, they were. I
was
mean,
it?
they had
Yeah.
their own
Mm,
wing design there. I'm trying to think of it.
mm,
I think it was a designer though, very specifically a designer over there that was
yeah.
chasing this. Prandtl had one piece, Horton had another, and there was a, the guy who did the wingtips,
Mm,
and I'm blanking on his name. I don't have it in front of me.
yeah.
Um,
Okay.
but yeah, I think the three of them were tackling the same problem
Right.
and trying to solve that phenomena that happens at the wingtips and try to figure out, well, why does this? It works with the birds. Why doesn't it work here? What are we
Yeah.
missing?
Exactly. Yeah. Based on birds. Yeah.
Which is
Mm.
pretty cool.
And
Anyway,
also, in fact, that there is talking about Prandtl. There is Clipson does have the Prandtl D wing as well,
it's
and I've
hanging on my
built.
wall back here.
Yeah, I have built that. You built this too, yeah.
Uh,
Have you flown
uh,
it?
no, it's a hangar
No.
queen at this point. It
Yeah.
doesn't have any electronics at the moment. I have to
Oh
feed
yeah.
some
Well,
electronics to it.
that was my trouble. Is it doesn't have a lot of space for electronics, so you're really cramped for because it's got a very very
Yeah,
small fuse section.
right. I feel
So
like if I set up the control, see when I look at that, and it was the problem when I was trying to build the foam board version, is the
mm,
taper is so small. The wing section has, the chord value is what, half or a third of what it is at the root, and
yeah,
so
I
the
think so.
thickness of that wing, it's a it's a very thin symmetrical wing chord section. So you're not even looking like 8% maybe. So
Mm,
it's so small. And I'm thinking the only way to really get good control surfaces, honestly, to do a pull floss, or some sort of like steel, like light gauge steel wire, right? And then you like fishing. They have a metal fishing line. It's just like one or two
okay.
filaments, and that's really
Mhm,
super strong, and it doesn't stretch a whole lot. I can't
mm,
remember what it is. Um, but you can do a pull setup. That's a lot of the gliders will use something like that because it's very
okay.
lightweight, right? And you can run the lines over a couple little pulleys or we'll call freely rotating, actuating like rollers almost because
Mm,
the distance you're rolling is actually pretty small. So, and then you bring it to a servo that's like right at the center of mass. So then you're not
mm,
making weird
mm,
weight. You're not having to put extra weight in front to balance out the servo you had to put, or the wire that you had to run all the way back, the
mm.
heavy, whatever you're doing. So I was thinking
I
like that might be
yeah.
a solution for this wing where you put the
Mm,
servo near the base, you run it through like this kind of rocker mechanism in the wing, and then out to the pull setup. So you have a wire on top and a wire on the bottom, and they hook into either side of the servo arm. You put in instead of a single arm, you put a T, right?
okay.
And then
Yeah.
so both sides are actually doing work,
Yeah. Is that
but it's only
is
intentional
that
one.
is that like more like the Bloody Baron type of thing where you have like a central servo?
Yeah, kind of like that,
Yeah,
right?
yeah,
Where you keep the servos in the middle, and then
yeah.
you run instead of running a
Well, yeah,
wire, like
yeah,
you can
yeah.
either run it to a torque tube, right,
Mm,
that runs the length of the wing, or you
mhm,
run wire out to the tips and then kind of
mm.
turn them back to the control surface. And
Yeah,
the
'cause
surface gets attached on the top and bottom, and then only one side is ever in tension. So you can actually create you know, very lightweight, one strand of carbon fiber filament would probably be plenty strong if it was bendable into it, like you put it on a knot, but it's, it'd be
Well,
useless in push, but it'd be great in pull, and that creates lightweight
I
controls.
mean, I guess my mistake when I did a maiden of the Prandtl D wing, I'd had it like you. It was hanging on my wall for a long time, and I finally decided to
Let's do
launch
it.
it.
Yeah.
And that was several months back. Now I can't remember exactly when, but I have a dolly, for launching.
Yes, that's so smart.
Stuff. Yeah, and I don't know what happened, but I have the video. It kind of it went along, tracked okay, and then the thing just did a completely 180 degree.
Like
and
one
the
of the
whole,
wingtips caught or something, and it
yeah,
rotated that way.
I
Yawed?
don't know.
Or was it a yaw, or was it a flip back?
It was more of a yaw. Yeah.
Yeah. Okay. That's
So
that's not what I would expect.
I mean, I have this dolly for the F-16. I mainly designed it for the F-16 Ben Harbour's F-16.
I remember that. I remember seeing
Yeah,
that in the video.
which is a couple of years ago. But I've got another design that has a steerable dolly, which is another project of the many projects I have on my list, where it's got a servo in there to actually steer it. Because the trouble with a dolly, if it's got fixed wheels, it will tend to move left or right. It doesn't track perfectly, down the runway. So then you end up sometimes, sometimes in the field. Whereas if you have a steerable one, then you connect that to the do it like a dual radio setup. I can do that with ELRS. And so that's that's down the road. That's my aim. But and I will reprint the Prandtl one of these days to get it off the ground. But
again, I hope you get an experience. I hope that you find success with it, because I felt that the flight characteristics, flying it was like no other plane I'd ever flown.
Well, I think Al Boa said the problem wasn't the flying; it was actually it didn't want to land.
Yes, there's that too.
But
that's almost any glider, right? Like if you don't have spoilers, right, and you have a glider, you are almost guaranteed you're going to eat up all that runway, because the glide slope is so tiny, right? If you are at the end of the runway at 10 feet off the ground at a 60-to-1 glide ratio, you've eaten up most of your runway just getting to the ground, let alone slowing down and stopping, right? So it's honestly, it makes pretty good sense, but it's having spoilers is important for that kind of plane.
Yeah, I mean, actually, an interesting project would be like an XL version of that, where you could have a bit more room in the in the fuselage part.
Yeah, and and then the wingtips are still so thin that you really got to pay attention to how. That's what I was worried about. It's how do you work the strength value so that you can actually have it so it's not flexing like crazy.
And also to fit it in my car as well, that would be a problem because it's just a wing.
I think. Oh no! I believe me. I'm telling you, I've run those scenarios. I want to build a much larger one. I would love to bring one.
That's what I'm. Yeah, I mean, I'm into XL. All my future builds are going to be XLs. I mean, I for a start, the XLs, they're easy to see. Once you get in the air. They're more stable. They're more stable in wind. And they take
more gentle.
And you've got plenty of room. This is my big thing about small planes, is that you don't. I always put an Aurora 5 light in my planes, and sometimes, especially in the Prandtl, there wasn't room to put one. Because you can't. There's no room for it.
Right.
So yeah, big planes are good. I like them.
Yeah, I'm finding myself. Well, I mean, obviously, I'm working on a full scale, right?
Yeah.
So
yeah, well there you go. That should have enough room.
I'm like, well,
Yeah.
if we just take this thing and double it, that's full scale. So let's just
Yeah.
build a full scale. Um,
Yeah, so that anyway, that's my last few
no,
weeks of building.
well, that's been busy. As far as RC is concerned, that's a lot busier than I've been. I mean, what I've done is after we talked the other little while back, I downloaded Orca, and I remembered I already bought the Quickie Q2 3D printed model, right? To
Oh yeah.
print it out and make it RC. So I said, okay, well, you know what? I'm going to go do that. I'm going to go print that out. And so that's actually what I started doing is I started arranging it on the plates. I think I've got it ready, so I'll probably start printing tonight. I'm going to print it out in, I don't know if this is a mistake or not, because it could be. But I think I'm going to print it out in like golden silk PLA because I happen to have some. I was like, oh, that could be really good looking. You know, I'm like, I mean, I could do lightweight PLA. But I think if I do the initial that way and realize, if it's too heavy, then I can always go back and print.
Well, it's definitely a lot easier to print in regular PLA, but yes, if it's a large enough plane, you can get away with it.
I think it is like, I think the wing sections are like 2 build plates wide as 1/2, right? So it's total 4 build plates. So I think you're looking at, again, it's looking somewhere around 4 to 5 feet for the wingspans.
Oh yeah, that's big. Yeah,
well, and it's a tandem wing, so there's a lot of wing.
Okay.
I could be wrong. I don't know. When it was 200 was it 200 millimeters? Is how was that 8 inches? So 8, 16, 32. Okay, so it's like 3 feet. I think is what it's going to be.
That's probably on the limit for. Yeah. I mean, basically, yeah. It's like the smaller the plane, the lighter it really needs to be. So
yes, yeah.
Because you don't have the wing. I mean, the air doesn't change, does it? The density of the air doesn't change.
Right. So, the lifting capacity of air is the same. It doesn't change with scale. So
yeah. So now you're stuck with a less wing area, and then your weight then tends to be more significant.
Right. So, and then the other thing I was considering was doing the fuselage in PLA, because that's not true. That's not going to take the brunt of any. Well, anyway, I had a theory. It doesn't matter. I'll probably be wrong and just experience whatever happens.
Well, actually, what you mentioned there that reminds me about when I did the beta testing for the Eclipse on Model C V2. It turned out that they ended up making pretty much the major part of the fuselage in regular PLA. Okay, the tail section was still going to be lightweight PLA, and the wing was still going to be lightweight PLA. But during the beta testing, different people use different combinations. Some have all of it PLA, but it's true that the lightweight PLA is probably a little bit more fragile. It's not as robust as the regular PLA, but of course it's lighter. So if you're doing some pretty rough landings, then in fact that happened this morning. A friend of mine built the V2. His plane didn't survive very well.
Oh, boo!
But yeah, and the thing is that's the thing with 3D printed planes.
Yeah, I mean it is what it is, right?
They're not. They can be looking. They can be made very good looking because you've got the ability to shape the whole plane, but they're not quite as robust as the foam board planes, which is why I like both. 3D printed planes and foam board planes.
They each have their place. I know that there's Andy RC just released a video on something that I've wanted to do forever. And I think there's a guy who solved the problem. I hope it's not just because they're using UK protocol cameras and the refresh rate's different. But he's using FPV, like HD FPV, right, with his buddy. He's got head tracker, so he can move his thing, and he's sitting in like a mall or same kind of deal with a STOL kind of aircraft, but he's got two LCDs that are
Mhm.
tied, of course, that are tied to the flight controller board, and it projects the information on the screen that you're getting from the flight control board as if they were dials,
All right.
and like a
Mm.
map screen, and you
Mm.
can toggle on your controller, like overhead radar, and different kind of screen outputs, as if you were in the airplane and you were toggling your Garmin, and you're
Mhm.
going to
Like a
weather,
yeah,
bow weather and stuff like that. Yeah.
like a HUD, like a
Yeah,
you know.
yeah, with like a like a
Mhm.
like a little HUD. I mean, the
Mm.
video feed will probably have the HUD stuff because that
Mm.
comes from the flight controller board too.
Mm.
That generally has it, but the actual cockpit of the plane has two screens in there, and
All
the
right.
screens have the little dials, and it's like the airspeed is,
Yeah.
every
But,
one of those has their
yeah.
altitude, altimeter
Mm.
is,
So he has it. He basically displays it inside the aircraft,
it's
and
in
then
the
has a,
aircraft, right?
and then does it have a camera pointing to those screens?
Correct. Yeah, he has an HD camera set in a spot where
Mhm.
you'd be as a pilot, and he
Yeah, yeah.
actually has it on a slider, so you can
Mm.
kind of get forward a little bit, like
Oh,
lean
interesting.
forward, so you can kind of look around, and then it kind of
Mm.
pulls back, so you can see more screen.
Mm.
Um, I'll forward you
Yeah, yeah, that
that
would be
video.
interesting.
It is.
Mm.
Andy RC is somebody who was using,
Mm.
he was doing drones, a lot of drones, and I think
Mm.
he battled a lot with depression, and there was, COVID threw everybody for a loop. He's
Mm.
no exception. And he kind of like, I do this stuff, and it's like I keep getting, we keep getting beat up every time we try to go out and do a thing and have fun. And it's like, this doesn't make me feel good. And somebody's like, well, why don't we just go fly my plane over here? Like, let's just go have fun. Who cares? Don't make videos. Just come out and have fun with me. And so he did that. And then he's like, well, what if we put a camera in it? Because obviously all the drones have the camera stuff on it. So he's
Yep.
like, or the quadcopter. So he threw that in there. And then his buddy's like, oh my God, this is the best. And he's like, yeah, that's what I'm talking about. And he goes, so they started flying around and they fly together. And now and so he's doing that. So I want to order that system, because to me, that's like the polish. That's the polish on, like, when I find what I'm looking for, that craft that I'm like, I love this craft, I'm just going to fly it. It's
Mm.
going to be my go-to, and I'm going to always have it.
Yeah.
That's the one where I put all the cockpit stuff, and I make sure I've got HD video and that kind of fun.
Mhm.
So
That would be good.
yeah, I'll lean that. So I was looking at
Yeah.
that, but I'm thinking, if I do the quickie, I'm 3D printing the quickie I want to get that started tonight. The needle cutter, you helped me out with one of the files, so that I'm gonna run that tonight as well, and see if I can't get that running. Because if I get the foam board running, then I just have to spend a day or two kind of running through some cut files,
Mhm.
from files I already have for the thing I want to go build for Flight Fest. So that'll actually take out some time of cutting. Although I kind of find the cutting of foam board to be kind of zen.
Mm.
It kind of brings your mind space to a certain place that you can kind of, I don't know, zone out and become peaceful with the world. And
There is something therapeutic about building out of foam board.
yeah,
Yeah,
there's something about it.
Yeah. It's not. You don't get the same. I don't get the same thing with 3D printing, but
No,
putting together foam board planes is quite
yeah,
quite nice.
there's something in that process, like you said, it's very
Yeah.
therapeutic. So I mean, part of me will miss a little bit of that, but at the same point, I also
Mm.
don't. I mean, what I'm aiming for and the time zone, like, it's what, a month away ish, a
Oh
little bit
yeah, yeah.
more. I don't have time. I need to be building right
Right,
now
yeah.
and doing my final tests in a couple weeks.
Is the plan
Like,
to build another giant?
it is, as dumb as I am. Yes,
Giant
I'm going to
new,
repair this old bird here with the
Mm.
twin motors. I have to mount the other motor back on. That won't take terribly long, but I got to pull it out from the depths of this room. And I'll get that running.
Mm.
I probably won't fly it much, but I'll have it running and get it ready. And what I'll probably do is, if I have time after the project, I'll probably just double check my light setup, because I did put lights in there. Because I would like to actually try the lights on it. It just, I didn't have the cojones last time. I was barely getting it in the air last time.
Yeah.
Now it's working, so I want to just take it out there
Mm.
and fly it and just enjoy flying it around, you know?
Yes.
So yeah, I mean, that's kind of what I've been doing. I've also been doing full-scale flight lessons.
Mhm.
I've been kind of back at that, which has been good. I'm feeling really comfortable with the landings now. I think my trainer has felt the same way. So we're getting to that spot where it's going to be like, hey, we're going to do cross country and you're getting your solo, and then you're going to go cross country, and it won't work on this other stuff. You're going to get the heck out of here as a pilot soon. Get going.
Mhm.
So that'll
Yeah,
be
good.
fun
Yeah.
if I can just schedule my time.
Right.
But that all that stuff, and it brings us back around to so and you were on our episode not too long ago. In episode 98, we talked about float flying,
Mhm.
which is, I think this is episode 104, maybe 105. We'll figure it out. Episode 52 is the first time we talked to you. We had you on to just talk about, I think at that point we were talking about 3D printing and the possibilities, what
Actually,
it brought.
we talked about this building this plane. No,
Yes. Yeah, they had the contest.
the contest and stuff. Yeah, yeah,
Right.
yeah.
We had that, but
In fact, now you mention it, my one of my projects is to make a 3D printed version of this plane.
excellent. That'd be awesome.
Yeah,
Oh,
yeah,
that'd be really fun to
yeah,
see.
yeah. Whether it happens this year is doesn't matter. But I mean, I still need to go into the CAD stuff much
Yeah.
more. You know, I
You have
need
like,
to do more.
you have half
Yeah.
a year. You got plenty of time.
Yeah, no, I'd like
I,
to. I was going to do another, like another foam board, and I thought, what I should really do, I should really, try to design
scale it
my
up.
own 3D printed plane. I think
Yeah.
Joe was trying to
Yeah,
get
Joe's
something.
been,
Yeah.
yeah, I was kind of hoping to see where he was
Mm.
at with his project. I know he shared some pretty big news today. Both Joe and I have some pretty, life, I don't know about life changing, but life going forward will be different for either of us. He's been looking for a house, and so he ended up actually finding a house. So I look forward to next time we get to talk to him. He can tell us more about it. But that's big news for him. So after his whole, once he goes through the whole process, because Richard, you and I have bought a couple houses, I think by now, and it's a
Yep.
process. I'm
Mhm.
just going to leave it at that.
Well, we were considering moving because we're in a two-story house, and as we get older, it's more difficult to get down the stairs,
Yeah.
particularly for my wife. And we were looking at moving to maybe a single-story house, but just the hassle of moving,
Oh yeah.
and with the current house prices and stuff, even if you're going to sell your own house, you've still got to like transition to another house. No, we're gonna try to stay here, and if we have
Yeah.
to, we'll install an elevator. So
There you go.
that's something.
Have a little
That's something. Yeah, something we were looking into.
stair-bound people mover. You'd be all right.
Yeah.
Um, I think you were talking about the little scout, the micro scout, or the mini scout, and that was
There is a mini scout, and there is a regular scout, and now there's an XL scout.
there's an XL scout, and then there's also the gaggle scouts, and those are literally a different size. They're basically,
Oh,
it's like if you scaled down a regular scout to almost mini scout size.
Mm-hmm.
Because I built one. As a matter of fact, probably behind me here. I don't see it offhand, but it's close by. That's a handful. You really have to dial it in. But the Gotha Gaggle, the Gotha was a 1/6 scale Gotha bomber. So yeah, you got the scale right. So good for you. That's impressive. But yeah, and then of course they made a million different liveries to put on those, we'll call them mini scouts, because they were built the same way, but they were built for an F pack. Like the original scout is like a C pack,
B or C pack.
B or C, so it's like an 8 to 10 inch prop, and this one was built for a 5-inch prop, so that you could basically get a quadcopter set and just make 5 of these silly things and have fun. The problem is they're touchy, and
Yeah, I
that
can imagine.
mine was a little bit difficult to balance, and it was a hot mess. And again, when you had, I think there was like 50 of them in the air or something like at the time at one time. So I mean, people almost immediately lost their planes pretty quickly.
Yeah. No, well, like I said earlier, I really like the large planes now. I think
Yeah.
at least the 60-inch wingspan, is got to be.
No,
Yeah.
I agree. I think 60-inch seems to be big enough to see pretty easy. It's slow enough where I mean, you can make it a speed demon, but it also can go really slow if you just want to chill.
Yeah. Right.
It's transportable, barely.
Yeah.
But otherwise it's pretty good. I think it's a pretty sweet spot, where you're not
And
having
then,
to look out like, okay, let me get 10 pounds of stuff.
right. And I mean, 60 inches is about the limit you've got to get out of 2 sheets of foam board. So if you want to make, one half of the wing out of one, like they did with the XL, then you're kind of limited to that 30-inch. 30 inches for the half of the wing. So
yeah. I mean, you're limited kind of by them, not limited, but the material does tend to dictate the rough sizing. Like, I mean, if you're only you can only find your ball set in 48 inches. An easy build is an 8-foot plane, right?
Yeah.
You just 2 full-size sticks and let's go. So I think that's the same kind of deal where, depending on the material you have easily available, that tends to inform a number of your design choices, right? Because
exactly.
If I can easily fit this on, I mean, if we had access to 40-inch board, right, a 30 by 40-inch board, our planes would look very different. I'm pretty sure. So, well, okay, why don't we go and transition into we'll call our main topic. Our main topic is going back to relook at the 3D printing market and how it fits into the aviation hobby. We talked, in previous times about like it's great for creating custom details. You can create your own pilot, and you can scan yourself and make you a pilot in the plane. You can create your own dashboards. At this point, you can actually put the LEDs screens in the back and actually have active real-time, dials and instrument gauges in your plane if you want at this point. We might get into that a little bit more detail. I might see if I can reach out to the manufacturer of that. But that's a different thing. But I mean, most of the time it was pretty much like, oh, let me make a custom thing, or maybe I can make custom tires. Like, I can make my tread because I can download the thing and print it out on TPU. It was great for quadcopters with how do you stick your camera in so that it survived a crash, right? And so what they would do is they'd create these kind of rubberized plastic, safety cages for the cameras because they're pretty expensive. And so those were the common, if I remember, and then people started to figure out ways to print using PLA, which is kind of on the edge of density for its usability in an airplane. And then they started coming out with like lightweight PLA, which is like, oh, we're going to make this nozzle really hot, and the thing is going to start to just the gases are just going to expound like crazy, and the plastic will heat up and let that happen, and then it'll cool, and the bubbles will be bigger, and so it's less dense.
Well,
so somebody figured out how to do that, which is like, oh wait, this changes everything. Now we actually can build whatever we can dream up plane wise, print it out of lightweight PLA, and it's very similar to making it out of foam.
Well, I mean, I started out initially when my first 3D printer, I just used it to print out the flight test parts that were normally cut out with plywood. So like things like the firewall, which is normally. I mean, it's a lot easier to print out a 3D printed firewall than it is to cut it out in plywood.
Right. So, right, with precise holes as opposed to getting the old plywood and hoping you don't mess up the hole.
Exactly. So and then also the control horns, that typically come with the speed build kits. In fact, I think now they actually come with like plastic type instead of foam board. But So I mean, my first 3D printed stuff was really just the little parts that went together for the flight test planes, and then
Yeah.
around about the same time, a number of companies, not many companies at the time. This is like 3 or 4 years ago, maybe 5 years ago.
Right.
They came out with their whole planes, and in fact, if you go to the next slide, do you have the slides up there?
Yeah. Let's go to the slides.
Yeah.
Give me. You keep talking, and I'll bring it up.
Yeah. So Filament Flyer was just a bit of a name that I came up with. So eventually, I might end up making my own like have website and stuff, and to do this. But
Yeah.
This is the list of companies that I have. I haven't printed. I've printed some of the planes from these companies, but not all of them. But I mentioned this before. The Eclipse-on. That seems to be one of the major players in this business. They're actually based in Spain.
Okay.
They're and they're the ones that will offer, like, if you want to do a beta test. So I've probably printed more Eclipse-on planes than any other planes. But I mean, typically most of these sites will, either for a fee, and sometimes, not many of them, but some of them are free, just to get you started.
Yeah.
You can just download. Yeah, like Eclipse-on has a free plane that you can download. 3D Lab Print has a Piper J3 Club that you can download for free.
3D Aero Ventures has like a trainer plane.
Well, actually,
3D
Aero Ventures, which is Eric that you had on your episode 77. He used to charge for his things, but then when he left, and he basically provided all his planes for free, so you can download those. Yeah.
If you go, I'll remember the episode in a moment here, but
episode 77.
Go check out that episode if you want to hear, because he went through a number of the real story, but basically he was putting together a plane that I guess was close enough to a real thing, and it was copyrighted, or they felt it was, and he just like, I don't
that was that was like the infinite wing thing.
It was the box beam.
The box, in fact, I just funny you should say. Yeah, I re-listened to that. I re-listened to that episode just recently in preparation for this, and he did go into that quite a bit, and I think he spoke to somebody, and they weren't very cooperative. Like they thought they were infringing on their patent.
The lawyers weren't happy with him. So he's just like, you know what?
It's definitely worthwhile to re-listen to that if you want to get into 3D printing. Yeah, but now these ones, Eclipse-on, I've got they make, like I said, they make a number of planes. Got their website, 3D Lab Print.
They're one of the first ones, right?
In fact, I think they were the very first one that made print. And in fact, their very first ones did not use lightweight PLA. They just used the regular PLA, but their planes were at least 60-inch wingspans. So they were pretty large, and they needed to have large motors and large battery, like 4-6 cell batteries. Plane print is a good one. I haven't printed much from them.
I've got a couple, I think, from them.
Well, I've got their Icon 5, which is like a seaplane type of thing.
It's a boat. It's a boat hull plane design.
Interesting. The full scale version of that is pretty interesting if you look at the videos for that. It's a $500,000 plane, but And then Flightory is one I have printed. They tend to make more like fixed wing UAVs. Okay. So they're more into like the putting the cameras in a plane and flying them, doing like scanning the ground for crops, or the health of crops.
Which one was that?
Flytory, the Flytory
Okay.
one, the fourth one
Yeah.
down.
Okay. Got it.
Yeah,
Yeah.
yeah, yeah. So I've got, and I've actually printed off their Stallion. It's called the Stallion,
Yeah.
and they made a twin engine Stallion, which is basically just a twin engine UAV. But then
Right.
they made a kit to make it VTOL. So
Oh.
it's a tilt. So that they've got twin
So it's
engines
a.
on the wings at the front, and
Yep.
then the VTOL kit makes them tilted. Okay, and then
Okay.
you've got a third engine. So it's I
Yeah.
mean
Third engine.
third
Boom.
motor. Yeah, on the boom at the back. So I've got all that printed. I've got the motors. I've got all the electronics. I've got the flight controller. Just
Great.
it's just the question of putting it
Oh,
together.
look,
Yeah, yeah.
I love they created print it out of, we'll call clear PLA. You're not seeing the air quotes of
Mm,
clear,
right.
because I've got some of the see-through the clear stuff, and it's not quite clear, but it is really good as a diffuser,
Mm.
and they use that for the wing light diffusers, which
Oh,
is
okay.
smart,
Yeah, yeah, yeah.
really
No,
smart.
they've got several designs out there. Like I said, their main they don't come out with what warbirds or stuff like 3D layer print and clips on
Right?
and plane
No, no,
print,
no.
or
They're hitting a different market.
yeah, it is more like a UAV type style, and you
Yes.
typically want to have a flight controller in there, with something like running nav, iNav
Mhm.
or the other one. Yeah,
Yes, I know exactly. Beta flight.
but well, not so much beta flight.
Or you're talking about the automated,
Yeah, yeah, yeah.
Ardu
I,
Pilot,
ArduPilot.
iNav,
In
Ardu
fact,
Pilot, and then Beta
uh,
Flight.
yeah, I mean, I've got some experience with ArduPilot on drones. Some years
Mhm.
ago, I installed that. So I figured, I don't do much with drones these days, but I would like to, get this one, and I've got like a flight control. I'll probably end up, especially I think ArduPilot. You probably need ArduPilot because it's got the tilted front
Yeah,
rotors,
I
and I
think
don't,
so, because I know the
yeah,
iNav handles that well. The other ones handle it, but I don't think as well.
no, no. Well, yeah, I'm not even sure iNav does it.
It
That they might. I haven't kept up with the latest versions, but
Yeah,
I
I haven't.
know that ArduPilot does it. But
Mhm.
anyway, that's an interesting site because of the if you're really into like long, I know we're not meant to like fly um, beyond line of sight, but I mean these kind of planes are kind of designed for that. They're more like functional UAVs. And
Mhm.
then we mentioned before, Eric, you had Eric from, that created 3D Aero Ventures. He has some
Yep,
really nice models on his flight. And in fact,
he does.
I just, yeah, I mean, he's got this really, really large 3D printed B-17,
Yes.
and
Oh, that looks so beautiful. Are you
it's an
building that?
80. I am building it. Yes, I'm not building it for myself. I've been commissioned by a friend and fellow club member to build it. Well, not to build it for him, but to at least print it.
Okay.
And I'm probably in about the uh, fourth week of printing, and I probably have another 4 weeks of printing.
Wow.
I
I
mean,
mean, I get it, but
yeah,
wow.
yeah. No, no. I mean, some of the parts take over 24 hours to print. I mean, that is one of the problem, not the problems, but one of the things that if you are getting into 3D printing full scale, not full scale planes, but large uh, uh, 3D printed planes, RC planes, then the time. I mean, you're not actually doing anything while it's printing. You probably keep an eye on it from time to time in case it
Yeah.
goes wrong. But I usually typically leave it running overnight.
Well, and that's yeah,
Um,
and that's part of what I was one of the things I know we'll have a quick conversation about is
mm,
that there seems to, in the recent, we'll call it last 6 months or so, there's been, I'll call it a paradigm shift with the required maintenance that 3D printing requires nowadays. It used to require is very much a second hobby or third, or depending on how many you already have. It was definitely its own hobby, right? Like it took that kind of time where you'd have to kind of chase after the little weird things that happen as you go, and got to change the nozzle, double check this, and why is that not working? And you finally get it going, and it goes pretty well, and you print some amazing stuff for a while, and then something happens again, and you got to kind of chase it down, and that seemed to be the common, but and it goes, and everybody goes, well, and it kind of goes slow, right? Like it's not stupid fast. Like you print a thing and you're going to be done at the end of the day, right? You put a build plate worth of stuff and you go to work and you come back after 8 hours and maybe you have spaghetti, maybe, but mostly you're hoping to have like finished parts, right?
Yeah.
You have a plate full of parts. But nowadays that's changed.
Yeah, it's
right?
definitely getting more reliable. Yeah.
Yeah. And speed is like doubled or tripled.
Well, the problem with I mean the speed of printers has doubled. Well, actually, in fact, I would say that the speed is now like tenfold.
Yeah,
On
I agree
some
with that
things. Yeah,
assessment.
the problem, and I basically mentioned this in the slides, is the lightweight PLA you cannot print very fast.
Okay. Well, we
So
can get into that later, but I just, it seems to be like that's the big paradigm, right? Like you got all these guys who've done this, right? And part of the drawbacks that I've heard from people is not just from 3D printing, but just printing one of these planes. Like there's so much to print, and it's like I've got to dedicate keeping up with this printing process for a week or two. Right. And that doesn't include the assembly, right? That's just getting the parts printed. And it's like, oh geez. That's too much for a number of people. But other people but when I'm done, it's like a perfect replica. This is awesome.
Yes. I mean, it's a scale plane, so and the thing is if how long does it take people to build a balsa plane? I mean,
right.
As what I remember from building balsa planes as a kid, or at least my father building them, it used to take 6 months to build a plane, so but no, I mean there's I mean, and most of these, I mean you obviously have to pay for the files and
I mean you're paying for the work that they did to create this so that you can just print it.
And it's a lot of work. I mean, some of these guys, some of these companies put, maybe 2 or 3 years into design and a model, so it's not it's not a trivial task, to design something. So and then we mentioned 3D Aero Ventures. Brian McKellen, he used to do like some of these. He's got a
YouTube do a lot of
channel.
Reviews. Right.
A lot of reviews, but more recently, he's actually designed his own planes.
Great.
And which is also available. I think you can purchase them, but they're mainly airlines.
Airliners, yeah. He seems to love airliners.
Oh well, I think it's because he's an airline pilot.
Well, that makes sense.
So, at least as far as I know, he's an airline pilot. So
yeah, I was gonna say like some people love airliners, right? They love jets, and they're kind of they're not terribly approachable as far as like, oh, I'll just build one of these. A lot of people have a hard time saying that's what I'm going to do, partly because the fuselage is so darn long. Like you have to have an easy way to tear it apart and put it back together because
I mean,
in your car.
His planes are large. I mean, they're pretty big as well, and the closest I've come to probably building one of his is the C-47, so which is basically a DC-3, So, but he's got some impressive planes.
Right, he has a C-17.
Yeah,
and because it's 3D printed, you can size it up however you want to a degree.
Yeah. So no, it's very he's got a lot of reputation in the 3D printed model area there. Titan Dynamics, I haven't really built any of those. They're kind of similar to Flight Tory. They do a lot of UAV type style planes,
That's what it looks like.
Yeah,
There are
Airplanes,
FPV platforms and
yeah,
VTOLs.
exactly. FPV is probably a more appropriate word for it. Yeah, yeah. So where you're going to put a camera in, you're going to do some, maybe some. Well, I mean, minimum FPV, but you're probably going to do some, use it for some sort of video recording and stuff, more like a drone type of thing. Yeah, like a fixed wing drone. Yeah, fixed wing
If
drone.
you'd need to do some reconnaissance or
Yeah.
just review an area from afar. Yeah.
Airplanes I've looked at, they're a really interesting site. It doesn't. They've got some really well animated. If you go to their website, they've got some very nice animated ad drawings of their planes. They seem to be they seem to be really into jets, mainly into jets. They've got like model F-16s, model F-18s. I think they're based in India.
Yes.
I think it's an Indian-based company.
It could be, and I know their printer of choice seems to be Bamboo Labs at this point.
I think a lot of these companies, like, for example, like Eclipson, were always a Cura type of thing, with Ender 3 type printers. The 3D Lab print were really into Prusa and Prusa Slicer and stuff. But a lot, I think they recognize that Bamboo is now, pretty much, become a dominant player in the market, 3D printing market.
Yep.
So a lot of these, a lot of these now are providing files, or at least profiles that would be compatible with the lab.
You go with you go with what people use. Like if this is what you have, let's go with it, right?
Right. And then I came across this site. He's just a loner. This guy, like Storecraft. He's mainly into like exactly what it says there. Like soaring planes. Like what do you call them? Like a glider that you would use for soaring and that. So he's got some interest.
They're all we'll call it performance gliding.
Performance gliding, yeah, that's probably a good thing. Yeah. He's got some nice designs. So,
Yep.
Trouble is, I mean, these guys are producing planes all over the place, and it's difficult to keep up with them. Bastillero, how you would pronounce that?
Bastillero? Yeah.
Bastillero, yeah. They've got a very nice P-47, a large one. Which is pretty. I mean, again, that's going to be a pretty ambitious project to build, but it's a really nice scale looking. And they've got some other product. They don't have many planes, but the planes that they do have are pretty big and pretty. They're like success. You've got to put success batteries in them, and pretty much like scale type planes. And
they also have scale pilots.
Yes, they do. Yes, good point. Yeah, if you're looking at their website, they've got pilots that you can download and add to them. And all these, you have to pay for the files and everything, but they're pretty reasonable, cost and everything.
Yeah, it seems to be.
Yeah. I mean, the cost of the airframe typically when you're 3D printing is not that much. I would say, you're talking about, depending on the size of the plane, usually out of one reel of if you were like talking about a 40-inch wingspan plane, you could probably get 3 or 4 planes or 3 or 4 airframes out of one reel of filament. So it's very probably not as economical as foam board, but it's still pretty economical. It's still pretty cheap. I mean, the major part of the cost is still going to be your electronics, your ESCs, your motors and stuff. That's
right.
Like
kind of like with most. I think the big, draw for many of us is probably the scale details you can ensure are part of the plane. And that's part of the part. Like I'm just looking at Bastillero, their level of detail for the dashboard, and that their machine guns have, it's not just 4 pipes sticking out the front. It's no, they have a scale model of the machine gun in there. Like it's.
Yes, these guys are serious.
Those guys are. Oof, that's awesome. That's really good.
And then Yeah, and then this lofted area is
Yep.
you might be interested in that one as well, because they've got even more sophisticated designs, including when I was looking at the Valkyrie,
Oh
um,
yeah. Those are the
which
VTOL
is
guys.
this is the well, the Valkyrie is I think it's like, isn't that
It's like a
um,
drone version.
there's a drone, but it's an unmanned full
Yeah.
scale version that's under development still with the US Air Force, I guess,
Goodness me.
But
They've got
there's
they call it a glow stick, which is an LED. It's a stick, so it's really basic. But they threw so many LEDs in there. But I think I'll call it their claim to fame is the F-35B swivel
yeah.
exhaust system.
Oh, that is pretty impressive. Yeah.
I'm tempted just to buy. Oh my god! Like part of me is just I drool over that model
I know.
only because the concept of the swiveling engine to me, I have other projects that I want to use that kind of tech in. So yeah, I'll leave that there. We can keep moving.
Yeah. Well, I mean, this is probably not an exhaustive list, but these
No,
are
but
just the
it's
ones I've come. These are the ones I've come across. They're actually just good to visit, just to get a taste of what you can actually do with 3D printing. And you can go from very basic planes to really sophisticated RC models. And then of course there are some models as far as I know on Thingiverse. And
yes.
and some of the smaller designers will post for a fee on Colts 3D, which is another kind of like website for downloadable files for 3D printing. So and then if you just go back up to the top here, typically the things that you get when you buy one of these models is you'll get typically STL files, which is obviously we'll go into that, but you'll get STL files, you'll get G codes, and in some cases you'll get 3MF files. But we'll go into that afterwards.
Okay.
But one of the big things, even if you know 3D printing, the difference between like just 3D printing, any other stuff, is the filament. And so if you go on to the next slide, it kind of goes over the filament stuff, Matt.
Yep.
Yeah. So I mean, the lightweight filament only came out probably about maybe 3 or 4 years ago. But it's and there's, like I mentioned here, there's two types of lightweight filament. There's what they call active foaming filament, and there's passive foaming or pre-foamed filament. And this is actually a point of confusion. I've noticed that on the various forums and Facebook groups, people end up buying the pre-foamed, thinking it's lightweight, and then trying to print a plane that is designed for the active foaming. So they've So that needs to be because it's totally different. Okay, so what the active foaming means is that it's the filament as it passes through the hot end as it's heated up, it expands. Okay, so it expands like a regular foam. So it basically comes much lighter because of the expansion. And so it's about it depends. Okay, so there's another slide here that kind of determines how much it expands or how much it is a lot less weight than regular PLA. But typically it's around half the weight of PLA, which is pretty significant.
It is.
So and as far as I can see, the only real practical use for it is making airplanes. There's and this is if you look at most of those companies will tell you whether to use lightweight active foaming. Not many use pre-foamed. Okay, I've used pre-foamed. It's not it. The thing is with pre-foamed, what that means is it's already been expanded at the factory. Okay, so you're not expanding it in your 3D printer. It's already been expanded.
Is that a
Okay.
good or a bad thing?
Well, what it makes it a lot easier to print in terms of like settings. Basically, you can almost print it the same way that you can print regular PLA. Okay.
Okay.
And so in terms of like settings, it's but the settings, you definitely don't want to buy, like I said earlier, you don't want to buy passive foaming and try to print it as lightweight, active foaming, because that will completely mess things up.
Yeah. What's the do you know what the density comparison is? Like if PLA is 1, right?
Okay, yeah. So what
Lightweight is what, 50 or?
yeah. So basically, what I did is I printed off the 3 identical. This is some time ago, just to do a comparison. I printed off
Yeah.
3 parts, all the same part of a plane. Okay, I think it's like the nose section, and so the regular PLA was like 40 grams. Okay, and
Right.
the lightweight, the active foaming one was 20 grams. Pretty much.
Okay. Yeah, it's like half the weight. That's
Okay, and then I printed off the passive foaming, and that was 30 grams. So like in between
interesting.
the two. Yeah.
Huh.
So it's like it's in fact there's only one, as far as I know, there's only one manufacturer that makes the and that's shows you on the next slide there. But
Yep.
the other thing, obviously, to point out here is that you definitely need to be aware of this, because you would look up, if you go on like Amazon and you look up lightweight PLA, you'll probably end up with a passive foaming, which is not what you want in most cases.
Right.
I would say probably 90% of the of those companies that we saw on the previous slide will use the active foaming PLA.
Yeah. And that would be labeled, like if you're looking it up, it'd be LW-PLA as your
Well, the thing
search
is,
term.
no, even the passive foaming is sometimes labeled LWPLA, and that's
Oh
what's
boy.
that's what
So
causes confusion. Yeah.
so is active foaming the term you want to look for then?
Yes. You want to
Okay.
look. Well, we can go on. Well, just before we go on the next slide, there is obviously other material that you need in a plane. You
Right.
still need regular PLA, because some
Mhm.
parts, especially the small parts, they're going to be printed, with the regular PLA. PETG is a filament that has a much higher resilient to temperature, and
Right.
typically that's used for things like the firewall. Because
Yeah.
I mean, if the engine gets hot, if the motor gets hot, you don't want, and you've got a 3D printed firewall, and that applies to foam board planes too, if you're using those for foam
Right.
board planes. You want
Right.
to either,
Yeah.
you either want to print those firewalls in either PETG or ABS.
Okay. Right.
The trouble with
ABS
that,
is a
yeah,
higher top
well,
plastic.
yeah, I mean, the thing is,
ABS though, you got to worry about toxic
yeah,
fumes, right? You want to
exactly.
have
Yeah.
you want to make sure to have an exhaust.
Yeah. I mean, I
You
don't,
do.
my printer doesn't print. I don't print ABS for that reason.
Yeah, I think I have a
Um,
spool of ABS. I just need to print as many firewalls
yeah,
as I can lay down with that filament, and
yeah.
then I do the outside, and then I go, okay, I'm done.
But PETG, I think like the melting point of PETG is
Yep.
like 80 C, and
Right.
ABS is like 100 C. So
Right.
I mean, unless you're really, unless you're making the motor really, really hot, I don't think you have a problem with.
Yeah, at that point
Yeah,
you're desyncing the magnets, or you're in
yeah,
danger of that. I think at that point, not
yeah,
desyncing, but you start damaging the actual
right.
permanent magnets. I think at that
Yeah.
temperature.
And then the other material that we could use is TPU, which is
Oh
used
yeah.
is a flexible material, a flexible filament.
Mm-hmm.
So that's and there's actually a lightweight version of that, which is typically used for tires. So you can
Yes.
print your own
Tires
tires,
is
and
so
yeah.
awesome.
So I've just put a note in there just to mention these other, not to
Right.
forget these other. But typically the majority of the airframe these days is built out of, I would say, active foaming lightweight PLA.
Okay. I
So
know
if
a
you go
lot
on
of
it, yeah,
in the past, was it TPU was the one of the harder ones. Like lightweight PLA, you had to dial in temperature wise and feed rate wise, but like TPU was hard just because it's so flexible.
yes,
Is it still a pain in the butt with the newer printers?
Well, you
or
know, I mean,
you
yeah,
figured
I
it
mean,
out?
no, I mean, actually, you know, technically, you know, people say you can't, you can't use, you can't print TPU on a printer that's a Bowden as
Mhm.
opposed to a direct drive.
You can, but
But
it's not pretty.
I've not had no problem printing on an Ender 3 with a
Okay.
Bowden 2 with TPU. I've printed
Right.
loads of tires, yeah, on that.
Yeah, me too.
Yeah,
I had a bout that everything went well, and then I had a bout where it went poorly.
yeah.
I was like, oh well, I don't know.
I mean, the problem is, you know, you're trying to push a flexible material through, you know, maybe a 10-inch piece of tubing, but
Yeah.
you know, I think if the printer's set up properly, it's not a big problem.
Okay.
But yeah, I mean, uh, but and that may be because it's lightweight TPU. I don't know. Maybe that makes a difference. But I haven't printed a lot of like regular TPU. I've always used the lightweight TPU because that's, you know, typically what you do with,
Yeah.
you know, print tires. Yeah.
Right.
But
Yeah. No, that's ideal. But I know if you're like me, like I haven't bought any yet. So
mm,
I've got this giant spool of TPU, not a giant spool, but I have a full
mm.
spool. You know,
Is that just regular
if
TPU?
yeah, regular TPU, and I think I made
Mm,
it blue. I don't know if I have blue or black, but it's useful for again mounting cameras and anything you
mm.
know is going to be bumped against and
Yeah.
squished a bit. Like it's really great for that. But the cool part is you can do the infill, and based on how dense your infill is how much or little squish you get, and then how many layers you have of your tire, right? Like so you can actually get a pretty soft tire with
Mm.
TPU, just straight out TPU.
Yeah.
It's
You
pretty
can.
impressive.
I mean, I think they use it for cars and stuff. You know, you can
Yeah,
print
usually.
tires for cars. But you know, especially like the bush plane you know, I've just built here.
Yeah.
It's got big old fat tires, you know, so you want to really use the lightweight TPU as you can,
Hmm.
uh, because again, it's probably about half the weight of regular TPU.
Yeah, definitely.
Um,
Good.
but yeah, so if you go on the next slide, Matt, I think that just lists the companies. There's actually not that many companies that make lightweight PLA.
Right. It's like
I think,
color fab.
yeah,
eSun has some. 3D Print Lab has their own.
yeah, they do. So Color Labs was kind of the first. They were pioneered the lightweight material.
Yeah, they did.
Yeah, so they're actually based in the Netherlands. But I think last year, actually probably not far from where you are, they opened up a US distributor
Okay,
in
great.
I think it might have been, I think it's either South or North Carolina.
I'll take a look. Yeah, go
Yeah.
ahead.
So I guess, you know, because obviously, you know, ordering color fab print material from Europe was expensive if you're based in the US. Although I think Matter Hackers stocked it, but you know it was like it was like $25 if you bought it from Europe, but it was like $50
Yeah.
if you bought it from Matter Hackers. You know, so I did use the color fabs initially. It's definitely cheaper if you obviously buy it from the US distribution place. They also sell it on the flight test store. So I
Right.
noticed that the price there is pretty much the same. And actually, and now I think Lee at Windcatcher RC, he also stocks
Yes.
both color fab and 3D lab print material.
Okay.
Yeah.
Color
So,
Fab, their US is based out of New York City, I think.
oh, was it? I thought they were in
Yeah.
South Carolina. Okay.
Maybe they have a distribution down there, but
I thought that was where I think when I saw, I think when they, maybe that's where their warehouse is. Maybe their headquarters is in
yeah.
New York, but or their, yeah, but yeah, I'm pretty sure they announced a while back that they were opening up a warehouse in South Carolina. Anyway, but anyway,
And
and the same,
that very well could
yeah,
be.
yeah. Also, like 3D Lab Print, they're based in the Czech Republic, so you know, ordering
Yep.
from them was kind of pricey. until
the same
I
concerns, right?
I suggested to Lee that he stocks their stuff. So and now he does. So that's a good thing. And we just ordered some from him. And then eSun is, you can order that from Amazon.
How does that hold up comparative wise? Because eSun always seems to be easy to order from Amazon. Because they always seem to stock it.
No, I must admit I've not used the eSun. I've used the eSun PLA Plus, just the regular PLA, but I've not. At the moment, I always, all the planes, whether it's clips on, whether it's a 3D lab print, I always use the 3D lab print Polylight 1.0.
Okay.
For a couple of reasons. Okay. One, it gives a very nice finish. Okay. They've got nice colors that, I mean, basically they designed, so ColorFab's just designed lightweight PLA. 3D Lab Print, who designed planes, they designed the filament to make planes.
Yeah.
Okay. So their filament and their colors are kind of to match their models that they've designed. Right. And also the 3D Lab Print Polylight 1.0, it's so much cheaper because, as I mentioned here on the right, be careful when you order ColorFabs. It's actually a 750 gram reel. It's not a full 1K, not 1 kilogram. Whereas like the 3D Lab Print, that's 1 kilogram. Okay, so you're talking about a difference of if you work it out per kilogram. Okay, you I think the current price on Lee's website on Wingcatcher is like $37. Okay, for a reel, a 1 kilogram reel, whereas like ColorFabs is probably like $40-something, but for 750 grams. So there's
value. You got to pay attention to the value. Yeah.
Exactly. Yeah. So be careful not to get caught on that. And I personally, I would recommend the 3D Lab Print. I've not had any problems with that quality, and especially now you can get it from a US distributor. You don't have to. I mean, to get it from like the Czech Republic, with shipping and everything, you have to order like 4 reels to make it worth your while, because it's going to cost you the price of a reel to actually get it shipped over here. But I've done that. I did that before Lee took on
same
distribution.
Yeah, I think
and then
a ColorFab when they had the 750 gram reel, which I was like, why am I paying the same for less? But okay, this is what they have. And then they sold out of that, I think, at the time that I was buying. And they said, but we've got like a 5 kilogram roll. I'm like, you know what?
Yeah.
If I'm going to start printing planes, if I'm succeeding, I will probably continue to print planes. So you know what? Yeah. Let's get the big stuff. This is before I really knew some of the other aspects. But with these new printers, that might be back in style again.
Well, the other thing to remember with this lightweight PLA, okay, so you're actually pushing the lightweight PLA filament through the hot end of your printer at half the rate that you would normally put in regular PLA.
Right.
Okay. What that means is a 1 kilogram reel is effectively like a 2 kilogram reel of material. That's why
it goes twice as far, right?
It goes twice as far, and that's why you can get a number of airframes out of just one single reel. I mean, I would say you could probably get at least, sometime. I mean, I haven't really worked it out.
Which means I may never run out.
Yeah. So like maybe a 40-inch sort of wingspan plane. You probably get 3 or 4 of those out of one reel. So it's very, very economical, even though it's more expensive than regular PLA per reel. It's actually it works out about the same price in terms of volume. Printing.
Important considerations when you're trying to figure out is this project worth following up on. So
again, and this now. So this is the lightweight. So actually, just go back on that previous slide, Matt, because I mentioned I just mentioned the so
Bamboo Labs.
yeah. Well, yeah. I mean, Bamboo Labs have their own. Again, that's I've got one reel. I haven't really used it very much. Like, the rumor is it's just basically a rebranding of the eSun lightweight PLA. So I'm not sure. At least that's what my son-in-law told me.
Okay.
And then you've got the passive foaming pre-foamed lightweight PLA.
Right.
So that's when if it comes from Polymaker, okay. And there's nothing wrong with that. I mean, I'm not saying that.
No, just you got to understand you're not getting the weight savings.
No, and it may be a bit stronger, So
right.
In fact,
it may be worth it.
In fact, the only plane so far I've printed with it is the UAV from Flytory, the Stallion VTOL. They've got settings for both, like pre-foamed as well as, and I just happened to have a reel of pre-foamed that I wasn't using, so I ended up printing with that. So yeah, the settings are completely different. They're more closer to regular PLA settings because it's already been pre-foamed. Yeah. So and I think that, as far as I can tell, that they're the only ones that. But again, they call it, and this is the kicker, is that they call it Polylite, spelled LITE, whereas 3D lab prints call it Polylite, spelled LIGHT. So that's where the confusion, where that confusion comes. And I've answered several things on forums about this, and somebody's realised that they've been sold the wrong material. So yeah, that's the important part, and there may be some others out there. It's just that there is somewhat of a limited. There's loads and loads of companies making regular PLA, but there's a certain limited number of companies that are making the lightweight PLA. And then the lightweight TPU, initially there was, up until about a year or two ago, just color fabs. So you can, this is what you would use to print the tires. And now I think probably in maybe the last year or so, 3D Lab Print came out with their own version of the lightweight TPU. And in fact, today I just got a reel of that lightweight. I haven't actually used it myself, but I will print with that in the future. But I mean, I literally, probably I bought it because you're only printing tires, so you're not printing huge parts or anything. I had a whole reel of the Color Fabs lightweight TPU, and I think that must have lasted me like 3 years, maybe.
Yeah, I was going to say, with semi-frequent printing, that's got to last a long time.
And I printed tires for guys at the club. They would order,
hey, can you bring this? And they're like, yeah.
And I think some of these type tires are now on some apprentices and stuff, so just a cheap way of building, for tires. And then Lee at Windcatcher, he also stocks that Flexi Light, which is the 3D Lab Print equivalent.
Yeah.
So so there's that, and then I think on the next slide, what do I put on the next slide?
Yep. Hold on. There we go.
Oh yeah. So yeah, printing with lightweight filaments. Okay, so one of the things that's important when you're printing with lightweight PLA is the print speed. And which is a bit disappointing, really, because when I first got my Bamboo printer, thinking it could print at 500 millimeters a second, I thought, wow, I can print out planes really fast, But no, you can't print lightweight filament very fast. In fact, if you can try, but the quality won't be particularly that good. So yeah.
What is the critical piece of these? Like what, or they all have to be in perfect concert?
No, there's not like a, basically what you would do is you would use the recommendations that, so if you bought, say, a plane from, Eclipse on, they would have recommendations.
They have usually like
Yeah, yeah.
a print and assembly guide.
Yes, they'll have a they'll have a print and an assembly guide, and you can base it on those. And in fact, if you use the G codes, then it's all built into the G code, But so there's certain restrictions there as well. But just as a general rule, basically the density of the filament when it comes out of the printer is based on print speed, nozzle temp, that has to be adjusted, in the flow rate. So here you see the flow rate is about half what you normally. So the flow rate is how much filament you're pushing through the hot end. And so it's typically between 0.4 and 0.6. And I mean, when you play around with maybe these four things, or maybe at least three things, that will control the density. So again, you're basing it on, typically you would use, as close as possible, you'd use the recommended things as well. Well, you have to be careful there because, for example, like 3D lab print typically will use color fabs filament, so they'll have settings for color fabs filament.
Okay.
But say you're now printing, so now you're using 3D lab print,
Right.
So now you need to look up what 3D lab print is using. So like, for example, just to get an example, like nozzle temperature. So if I'm printing a clips-on plane with color fabs, I would probably print it at 235 C. Okay. But if I'm using color fabs filament, but if I'm using 3D lab print filament, I print it at 245 because the temperature is a little bit higher requirement for that filament. So this is where it's kind of a little bit complicated because you may be using not the same filament that the person that designed or the company that designed the plane, but you can usually get around it. They're pretty close, and
okay.
And then the other thing about printing with lightweight filament is it typically strings a lot. Okay, so the problem is it kind of so when the nozzle travels, so basically typically when a printer is printing, the filament is drawn back. Okay, you have it's called retraction.
It gets pushed and then it pulls back out a little bit.
So just before it travels, if it has to travel from one point of the part to another point, you get this retraction, and then when it comes to the other part, then you get this extrusion. Okay, well, the trouble with this lightweight PL, it oozes as it going across the travel part. It kind of oozes out. So
it's still expanding, right? Like you just shoved it through the expansion temperature.
Exactly. Yeah.
And it's not cooled off. Like it's still
it's still hot.
Heated.
And yeah. So the way that most of these companies have designed their planes is to try to minimize the amount of travel. Okay.
Right.
So initially they didn't do that, but they're more and more now, especially like Eclipse-on and 3D lab print, they're designing the plane so that they have almost zero travel. Okay. And if you look at the so I mean this, the top photo here on the right here this is typically what you'll end up with after you've printed for about 2 weeks of printing,
right. And you're like, oh my gosh, look at all these pieces, but they go together.
They go together pretty quickly.
Yeah, it's just like CA is what you used to put it together. Do you even use the kicker, or is it just
it depends, if I don't want to hold it together for like if I don't want to like hold it together for like 15-20 minutes or so, then I'll use the kicker, to which is what the accelerator. So I've got typically I mean once you've done the only thing is you really have to like do the dry fit parts, because obviously if you glue stuff together, and I've done this before, if you glue stuff together in the wrong order, you got to reprint that part again, pretty much.
Right, because it's not coming apart easy.
Pay attention to the build videos or whatever, which are not always great, so.
I know. I bought
But
the Eagle
so anyway, to avoid the stringing, and I don't know if you can see this very well, but this bottom photo, this is 3D Labs print section of an A10 wing section, okay? And every part of this, including the internal structure, is actually an external wall.
Right.
Does that make sense?
Yeah, and they print it as a vase, which is just running around the outside.
So basically, the nozzle never leaves, never retracts. If you look at the pattern of this, it's very, very clever the way they've done it, is the internal structure is created at the same time as the external skin, okay? And that completely avoids travel, okay? But obviously that has to be that has to be designed in the CAD software, when they're developing the plane.
Yeah, definitely. That's really cool. PLA, and one of the solutions was to make all of the components kind of all one thing, so they can go into a single vase string to create the entire shape, and that way you don't have any stringing.
Yeah, the other thing is, well, normally the way that 3D printers print is they print one layer, and then they raise the nozzle up by usually something like 0.2 millimeters, and then they print the next layer and so on. But there's a feature in 3D printing that's called spiral or vase mode, where you basically can't continually, throughout that layer, you're actually gradually raising the nozzle. Yeah. And so, that's why it's called vase mode, because it's like printing like a vase. If you were printing, a vase. Yeah. So this has only been done probably in the last few models of 3D Lab Print and Eclipse on, but it pretty much not every part is printed in vase or a spiral mode, but there is a setting in the slicers to enable that, and you obviously have to do that, but that eliminates a lot of the. But there's a fair bit of work involved in the CAD part of the design in order to obviously support that. You can't just
because you literally have to assume the width of the filament and your lines. I think they technically can't touch, or there may be a setting where you can actually generate a single line from the shapes you have, and then it connects it or whatever.
Yeah. Well, typically the width of the nozzle is 0.4. You can get different widths, but usually the default is 0.4 millimeters, and so and when you're printing a plane, you're just using a single outer perimeter. So you're basically printing a 0. But because it squashes a bit, you actually end up with about 0.5 something, as the, if you put calipers on that piece of filament, it's usually around 0.5 something, which is about the ideal width. And then the other thing, you're going to what is good if you can watch for the weight. So what I typically do is whenever I print a part, I've got some little digital scales. I'll measure the weight, and then if the company provides the weights of all the parts, not all of them do. 3D Lab Print is pretty good at that. At least you can tell then, you can compare it with what their projected weight is. Compare, how close you got. That'll give you an indication of whether you printed it in the. But I mean, the most important thing with this whole 3D printing lightweight material is to have really good layer adhesion. Okay, every layer has to be stuck because you don't want the plane to suddenly split apart, be weak in certain parts and then split apart in midair.
Right. Now I know in the older printers, I'll call it the previous gen, which would be now I'm not Ender Pro, right? And that generation. This new generation, because it wouldn't happen often, but I mean, you had to pay attention because it happened on occasion. I feel like the latest generation, which is the Cobras and the Bamboo Lab printers and a couple other that are similar to that.
Mhm.
I mean, I didn't. It printed out of the box like it was printing perfect. It was perfect. I mean, there was like a small tiny defect here and there, but I mean, I would have been ecstatic at that print quality in any of my previous printers.
Yeah,
You know,
but I think it's not always the printer. It's actually the way it's been.
I agree.
Yeah,
Yeah, I
yeah,
mean, there's
yeah,
a lot of factors to that, but
yeah,
when
yeah.
I'm just like hit
Mm,
print, just do thing,
yeah.
and I see the result, I'm like, oh, there's this or this or this, and if I had seen that come out in the first generation or second generation, I would have been ecstatic. Like
Right.
what
No, yeah.
they're putting out as their base, like, it's okay. It's like, it's pretty darn
Well,
good quality.
I mean, the most important thing in 3D printing is that very, very first layer. If you
First
don't
layer,
get if you don't get a very, very good layer on the first
right?
layer, then sometimes it'll actually come away from the bed.
Yeah,
And so that's why things like auto bed leveling. The older printers, you had to mechanically level the bed.
yeah, right.
Auto printing is important and stuff. So, and Bamboo goes through this whole like 3 or 4 minutes of
Same,
self-testing.
yeah, same with the Cobra and some of
Yeah,
all the
with a
modern
cover,
ones
yeah,
too.
yeah, yeah, and so they pretty much, yeah, you're right. I mean, you don't have to worry about the printer not being, like set up. So the only factors
Yeah,
that really would affect the print is the filament. Well, is basically the settings. If you don't have the settings correct,
right.
no matter how good the printer is, that's not going to correct any errors in the printing. So the settings are important, and obviously the calibration, if you like, of the printer is important as well. Yeah.
Right,
So
exactly.
this slide here so basically there's basically three ways to typically to print parts of a 3D printed plane. If you can, it's actually quickest to use the G codes that they provide. So
Okay,
the G codes basically are all basically already been generated by the company, and they can be sent either put to an SD card on your printer, and you can just print directly from them. You don't have to
okay,
worry about settings and stuff. You may have to worry about things like I said earlier about the filament. If you're not using the exact filament that they used,
okay.
you may have to tweak that a bit. But like for example here, like just recently, I was printing Eric's B17,
Yeah,
and I pretty much used but I'm printing this on an Ender 3 because he when he designed this plane about 4 years ago, I think it's about maybe 4 or 5 years ago. We didn't have these bamboo
no.
printers or stuff. So he used I think he used a Prusa printer,
Hmm.
a Mark III Prusa.
I think that's what he said.
Now,
Yeah.
yeah, and they were pretty standard. I mean, Prusa is pretty like generic, in terms of the platform. And so and so a Prusa, in a way, the Prusa Mark III is kind of similar to the Ender 3. So I just ended up, chancing it and taking the G codes and just sending them to the printer, and I actually
Yeah.
got pretty good quality. But it took forever,
So the benefit of the G codes is that all the ideal settings are there for that, for
Yeah,
typically that printer and that filament. And it's also effectively pre-sliced. You're just
yeah, it's pre-sliced. So
it's
yeah,
all done.
exactly.
You don't
Yeah,
have
it's
to
all
worry
done.
about
Yeah,
any of that.
yeah. But the important thing is to note is that
You're
you
using
can
the
only
same.
you're using like they mentioned here. You either using the same printer that the G codes were designed for, or you're
Mhm.
using something a little bit generic. Like I think i3 Mark III is a generic. So, okay.
Mhm.
Now, what I had to do in this case, like when I was printing Eric's things, his parts for the B17, is I actually my Ender 3 has a and I couldn't use these on the Bamboo. because these are not compatible with the bamboo, So I use
Right.
them on, and the thing is, the bamboo, because this is printing very, very slow, because of the lightweight material. When he used it, lightweight material, he had to make it very,
The
pretty
speed
slow.
advantage doesn't happen.
Doesn't
Like, it doesn't.
no,
Work.
you can't leverage off the speed advantage of the bamboo or these high speed printers, which is unfortunate. I mean, hopefully one of these days
Yeah.
they come out with a high speed lightweight PLA, which would be
Right.
fantastic.
That would, and I'm sure that somebody's working on it now. I'm guessing, but
well, I've seen people
you're
on the
waiting for
forums.
the material to do its physical mechanical thing at that temperature. So, yeah, you're really kind of stuck with how fast that is, whatever that is.
And I think people pushed it. I typically will print around 40 millimeters a second. I think that's kind of like the average. People have pushed it up. I've read people have pushed it up to 70, and still got decent results.
Right.
But does it really matter if you have to wait an extra hour for the part to print? So
I know with you and me, it's like I'm doing something totally different anyway.
Exactly.
I don't care if it's 5 or 6 hours. I'm going to be gone for 8. So
yeah, and I mean, usually if I leave it running overnight, I don't care.
Yeah.
So. And some of the parts that Eric on it because it's a large plane, it's taken 24 hours. It's some of the sections of the fuselage took 24 hours to print. But so what I had to do here, you can hack the G code if you're somewhat familiar with the G code commands, because they're just simply text, So my printer does support auto bed leveling, but the Eric's G codes didn't have those in it. It didn't obviously have a printer that supports, So I just basically added the G29 here, which tells the printer to do an auto bed level. So and that's that was just one of the mods. So you can, for that, you're kind of limited. You could probably change things like temperature. So like if you look here, like the M104, that's setting the temperature to 250 degrees. Okay, so if you wanted it, to be a little bit less or a bit more, you could hack the G code, if you really want to.
And the M190 is probably setting the bed temperature to 60. Yeah, each one of those has a.
Yeah. I mean, they're pretty intuitive. I mean, you can go on. There's a whole website on all the different commands and stuff. And the other thing is, I noticed that one of the things I had problem with Eric's file was one piece of the fuselage. He'd obviously forgotten to center the piece. When he desliced it. So on his side, it would have been like right at the extreme right of the bed. Okay, but because my bed is a little bit smaller than the Prusa, it would have.
So now it's off the edge.
It would, so I had to do some other, hacking of the G code and there is another. There's a G92 that you can make it think it's, shifted, but that's
here.
Well, that's setting the extruder. That was part of the thing. But you can actually you can say G92 X10 after you homed the extruder,
so it changes the offset.
And then it thinks it's already at 10 to the right, rather than so
you're effectively shifting the head.
Shifting the whole thing,
even though it's not like you're shifting the bed effectively.
But then I noticed that it didn't really it didn't match up with the auto bed leveling. So that's another story. But so if you can, obviously it's good. You don't have to mess with settings.
Yeah, that's the benefit of having G code available.
Yeah. But you've got to look at the the files that you've just bought. They'll provide all of. I mean, I think pretty much most of the companies that you listed at the very beginning, they pretty much provide the G codes. But again, you've got to look at.
The quickie doesn't seem. It seems pretty sparse, at least what I have or what I found. But I mean, it's got all the files, but it doesn't. As far as having instructions with it,
no.
I'll have to go find them. That's okay.
So that's one way of printing. The other, if you go to the next slide, then of course, if you don't have the same, if you do have to have a different printer, or you want to print it on, you've got to use a slicer. Um, and, the slicer obviously needs to be compatible with your printer. You need to be able to add your printer to the slicer. What complicates things here is like Eclipse-on. Typically in the past, they always used the Cura slicer. Okay. Whereas like 3D Lab Print, they use the Prusa slicer, So
Right, because they were using Prusas, and if you've got
So,
Bamboos now, Bamboo has their own slicer.
And then Bamboo has Bamboo Studios, and then based off the Bamboo Studio is the Orca slicer, which you said you recently downloaded as well.
Download. I'm going to give it a try with the Cobra. I think Joe mentioned that's.
Yeah, that is. I did check. Yeah. Because the thing is that the difference mainly between the Bamboo Studio and the Orca slicer is Bamboo Studio just supports the Bamboo printers, or at least they have profiles for the different Bamboo printers. Whereas the Orca slicer, which is actually based on the Bamboo Studio, and actually Bamboo Studio, what I understood, is based on the Prusa slicer, then the Orca slicer added all the other printers to it. So you've got profiles for all the other printers. So I think one of those is, But so then, you'd have to use the STL files. So you'd load the STL, you'd get an STL
essentially
file.
Bring in the models, tell it the settings you want it to have.
Well,
let it slice it and make a G code.
Yeah, exactly. So this was going to generate the G code we saw on the previous page. But the thing is, the STL only contains the geometry, the shape itself. The triangles. It's like I think it describes all the triangles. It does not have the printer settings. Okay, so the STL does not contain printer settings. It just describes how the shape of the part that you're bringing in. So you then have to obviously go through the build instructions or the print instructions in order to know what settings, and there may be settings for different parts. The wing parts may have a certain setting. So you have to things like layers, layer thickness, a number of walls, a number of layers for the bottom layers and top, and so on like that. So it's more complicated because although and this was a problem prior to recently, maybe a year ago. Like I said, like 3D Lab Print, we're using a Prusa slicer. And Eclipse-on were mainly using Cura, and no one, they didn't have profiles for the Bamboo. So and then of course people started to buy Bamboo printers and kept asking, can you provide settings for the Bamboo printers? And finally, both companies did end up. If you go to their websites, they do have links to settings for the Bamboo printers.
Well, if your user base is, already if that's what they're using nowadays, then. I mean, you cater to it because that's the people who are going to recommend you later.
I mean, I was basically, trying to translate, all the Cura settings into Bamboo. Like I had big spreadsheets trying to compare. Of course, the settings in one slicer, they may mean the same thing or affect the same print part.
Right, yeah. Each one has their own proprietary name.
But their all naming convention is completely different, or can be, So that kind it's getting a lot better. And I think eventually, maybe some of the companies will just basically provide the G codes that have been printed on a Bamboo, for example. But trying to cater for all the different printers out there is kind of a bit of a challenge. I mean, if you
we demand no less.
Yeah, but so you do need to have the and actually the other one I listed here is the Simplify 3D. That was actually a very early on. That was what Eric uses at 3D Aero Ventures and what he used for the B-17. And I think that's what also 3D Lab Print used to use because they have a file. They had a file for the like the equivalent to the STL file for the actual shape of the and then they had another file for the settings. So that was kind of nice. Well, I mean, Simplify 3D used to be free, but now you have to pay a $200 license. I think it's just a one-off license for it.
Right.
But
I heard the same thing. Yeah.
Yeah, but mainly like you've done, a lot of people are going to the Orca slicer. There's some advantages, and I think we might see that on the next page.
Yeah, I was
With,
going to say one of the things that
yeah,
is so joyous is to be able to set out your whole project
yeah,
in a number of
yeah.
different print beds. And you
Beds,
say,
yeah,
I'm just going to print
yeah,
one today, two
yeah,
tomorrow, whatever.
yeah. So basically, what it does. So this is a standard that's been out for some time, called 3MF. I think it stands for like 3D manufacturing, something like that. Manufacturing, yeah, 3D manufacturing format. And the whole point was to have like a universal standard for the industry. But that didn't happen. So for example, like if you've got a three, and I found this out, if you've got a 3MF file provided by like 3D Lab Print, they provide 3MF files as well as STL files. So the 3MF files contain all the settings. That's the advantage. It's kind of like in between having the G codes. So basically, for a particular wing part, if I load the 3MF file into the slicer, it automatically loads all the settings. So then I can just basically generate the G code. Okay. But if I want to load a 3MF file that's been generated by the Prusa slicer into Bamboo, that doesn't work. And I don't know who's not following the standard or if there's problems. But
hey guys, stop it.
yeah. But like we spoke about a while back, is what I really like in Boo Slicer, and their 3MF files. So basically, what you can create is you can build a 3MF file, and you can build a more, and this doesn't exist as far as I know now in Prusa Slicer or Cura, where you have this multiple plates. So, for example, I'd create like this is like the wing section. Oh, this is all the wing parts needed for a particular model, and then you just save this to one 3MF file. And then later on, if you want to reprint it, you can just bring in the whole file, and it saves all the settings. So whenever you built this, and I think what's going to happen eventually, and it may already happened on some of these companies are just going to provide this, as a format, which would be a lot better because that way you could load in the,
you save your clients, like you save them time.
Exactly. Yeah.
Right. Like if one of the barriers is, I just bought a thing. It's like, well, I bought a thing, but I still got to put another hour and a half into getting it laid out, getting it set up, making sure the settings are right and all that stuff. And I got to still put it to the thing. I haven't even started to print yet. Like I don't even see my stuff yet.
No,
I go,
okay. No,
if you can cut out a half hour of setting everything up or an hour, then you just added, a bunch of value to your client list, right?
Oh yeah. And I did hear. I haven't actually bought it recently. I haven't bought a file where they've actually provided 3MF files for like this, already set up. But somebody told me that I think that's what I can't remember if it's Eclipse on or 3D Lab Print. They were going to, they're providing these types of files. So hopefully they do that at least in the future, because it makes it so much easy to manage. Otherwise, look, you may have several hundred parts to print in a 3D lab in a 3D printed plane. So grouping the parts together, the way I usually do it is I usually group like the wing, the fuselage, and then all the little bits like that are printed in regular PLA together. So that you don't have 200 plates. You have maybe 10 plates or something in one 3MF file.
Right.
But that is. I think that's definitely the way that things are going, and of course with the Orca slicer, you don't have to print on a Bamboo printer. You can print this on any printer that the Bamboo is compatible with.
Yeah, it has a pretty wide range.
Yeah. So
pretty cool.
Yeah. So they're kind of the three methods that you can use to print a plane that you purchase from one of those companies. And then I think the next slide, I just have CAD software. I mean, you don't need CAD software for, to print the planes, but what it's useful for, what I found it useful for, is making those little modifications. Like I had, you know how the motors are, the mounting screws for motors are not always, well, one of them is typically 19 millimeters across, and the other one I think is like 22. The mounting holes.
Right. Yeah, they're different. They're different
Yeah,
spacing.
and I wanted to have that like mirror imaged. So in one of the planes I'd purchased, and so I just went into Autodesk Fusion and basically loaded in the STL. You typically, you can't modify the whole thing. Depends on the CAD software, but you can make some. Basically what I'm saying is that you can if you know a bit about the CAD software, you can make some minor
right
changes
well, and
to existing files.
if you know what you're doing, you can also use existing files to fit. Like if I've got a camera, right? I want to put a camera in this thing and I want it to fit into a divot in the fuselage. Well, I can get the camera model or bulk it out, put it in, make a negative in the STL file, and then kind of build it out so it'll be a hole, right? Make it a shell, and then now you can print that with a camera mount built in.
Exactly.
A little hole in the back that you can put the wire through, and then you're not having to mold that at home. You're not going to have to take your hot knife or whatever method to get through the plastic and all that kind of stuff. So
yeah, and I mean mainly that's what I've used it for, is just making like small. I mean, eventually I would like Eric does with his planes. Is to design my own planes. I would like to get the Bristol Bristol M1C as a 3D printed plane one of these days. And I did a plug for these guys because I think they're fantastic. The bottom URL.
I've listed them. I think they provide an excellent product for somebody who's looking to learn more about CADing and how to use CADing in 3D printing.
Yeah,
very specific.
Yeah. I mean, it's not specific to it's not specific to like designing a plane. That's something else. There's a number of YouTube channels on that. Yeah.
But they're like, hey, look, if you want to use CAD to get your idea to be able to be 3D printed, like you got to get a software. There has to be some sort of interface. Let's help you get there, because everybody having your idea become reality is so rewarding, right? So
and also like Autodesk Fusion, there's they provide a free version, providing you're not using it for commercial use. In fact, I'm not sure how they police it, but you can actually make up to $1,000 in revenue.
So for small parts and pieces or ancillary parts to what you're selling, you can still feel comfortable using that to get.
I mean, it's a to me. I mean, I think for most people, it's a fairly steep learning curve. But I mean, it's worth it in the end once in fact, once you know one CAD software, it's pretty much similar to other CAD softwares. All the it's kind of the same sort of thing. Tinkercad is also Autodesk, and it's kind of, I think it was really designed for like kids at schools and stuff.
Yep.
But I've actually used it. It's been pretty useful
it's not a whole lot different than, I mean, the more professional versions have certainly far more robust features to add to it. But the concepts Tinkercad is the core of what all 3D modeling is. It's adding or subtracting various shapes. Right? And then making sure that you type out the exact dimensions, and that's it.
Yeah.
I mean, that's all it is. It's more involved, but
it's not like, I mean, apparently there's some people that do some really fantastic stuff with Tinkercad. It's pretty amazing. They've done some similar stuff that they've done with Autodesk Fusion, but that is totally free as well. SolidWorks, I think they do have a hobby version, but you do have to pay, I think, like $10 a month.
They have different things. I know for aircraft, Full scale. If you belong to EIA, they give a discount. I think you
Yeah.
get teleworks for like
Well, yeah.
$99, and it's like it's not. I don't think it. I think it's standalone. Like you pay once and you've got it.
Oh, okay.
Um,
Yeah.
and Onshape is kind of like an online free-ish version.
Well, yes. Well, they have both. They have an online and commercial. The mainly difference what I see between I like Onshape because the advantage with Onshape it just runs in a browser. Okay.
Right.
It'll also run on your phone. Okay. So there's even a mobile app that if you don't mind a small screen that designs things, but
well, I mean, if you have a tablet that's medium sized, you can.
Well, the thing is, actually, talking about full scale. There's actually a good video. I'll probably send it to you offline. With this one company that switched. I think they switched from either Autodesk or to Onshape, and that's what they do. They design full scale experimental planes.
Dark Arrow.
Dark Arrow. That's the guy. That's the people. Yeah.
Those guys are great.
Yeah. Dark Arrow. Yes. That's it.
It's a fully capable software. I mean, there's no other way to. I think you have to pay. Like if you're doing a wind tunnel kind of analysis and more robust mechanical engineering features, and you want to do a finite element analysis and stuff. Like I think if you want the higher end things, you're going to have to pay for those kind of things. But to get your idea in there and just make sure it all fits, that's all free.
Yeah, with Onshape, if you just sign up for the free version, and whatever you create becomes public. Okay.
Right. Okay. Right.
So if you don't want your design to become public, you need to pay for the version. Otherwise,
just name your stuff weird, and nobody will ever find it.
Yeah. Well, exactly. Yeah. So you can't like have privately owned files.
Right.
But it's all online. Yeah.
Yeah, I was gonna say I've dabbled in FreeCAD, and FreeCAD is great. To me, it was a great analog to the original 2D CAD, which obviously can be extrapolated. Although it's the full Monty, and it seems to be tackled a slightly different way, but it is an incredibly powerful tool as well.
Yeah, I've dabbled a little bit with it, but I've used Onshape. I've used Tinkercad and AutoFusion. I'm kind of now thinking about that they made quite a few changes to Onshape in the last couple of years, and I haven't used it for a while. But
yeah, it might be worth checking out again.
I think it might be worth like going back. And after I saw that video from Dark Arrow, they kind of were saying what a
Well, a lot of the YouTubers, I think once the Fusion thing went to like, I don't know what it went to, but after a bit they said, hey, everybody's got to start paying. And then people immediately started looking around like, well, what else is out here? Because what you want me to pay. I mean, the average hobbyist isn't going to be able to do that. So they're looking around, and I think that's where a lot of them found Onshape because it came at about the right time for that.
Well, yeah, I mean, the Autodesk does have that one. They do have that product that basically is free, but but you can't do everything with it. You can't do as much with it. There's certain things that you can't do, and I really. One thing I did come across is
I can't do my spirals or whatever. Like, well,
yeah. I mean, the only restriction I did come across was you can only have up to 10 editable
parts, right?
Edible parts. Yeah.
Part of your thing.
Yeah. So as soon as you hit that limit, then you think, oh, I can't save any more parts, but you can, because you can just make your other parts read only. So you can toggle parts from being, editable to free only. But it's just a bit inconvenient, that's all. So, but I think I might revisit Onshape. Yeah. And then I think the last thing. Oh, this is the number of planes that. Yeah. No, that's okay. No, you can go next.
Okay. Yeah, I think we covered everything.
Yeah. So this, if you want, if people are interested in, doing any of these projects, I've got build logs on the flight test forum. Not for everything that I've 3D printed, but some of the things
Right.
that for the majority, I try to, these days, if whether it's a foam board plane or if it's a 3D printed plane, I'll always kick off a build log on. And I actually just recently, what I did, I put this index onto that URL.
Right.
Okay, so there's an
Yeah, that's
index
a good
here.
plan.
Yeah.
Yeah, I really have used in the past the flight test forum, and really it's like wherever you feel most at home in whatever community. Like I know a lot of people like RC groups. Um, I'm partial to Flight Fest because I feel like they have a more I don't know a community that wants to see you get to the end and they're willing to share all of the ideas so that everybody can learn and move forward with it. Whereas RC groups tends to be a little bit more like, look at what I did. I'm not going to tell you how, but if you're careful and look at these pictures, and some people are pretty forthcoming with most of their stuff, but it's not the norm, I don't think.
No. Yeah, in fact, I only recently joined RC groups. I must admit, I was not a member of the RC groups.
Yeah,
like
but it's
most
also
people in LB.
it's so huge though. There's much there. And there's some really incredible projects that are being done. And if you want more than foam board, right? Like if you're looking at like, hey, did anybody make a fiberglass version? Like, dude, I promise you, if they made a build log in RC groups, it's over there. Like, and you can really get into some nitty gritty detail.
That was motivation to join RC groups. Was there was a build log for the 3D Aero Adventures B-17 that I'm currently printing. So I jumped on that. Eric had a link on his documentation. So
there's something about the format of the flight test forums.
I like it.
It's so easy to make a log.
Yeah, it is. You can upload photos. You can upload things, and it's pretty easy to reply to stuff.
Good.
So basically what I've got is now an index to this to all the build logs.
That's a really good idea.
And actually if you look at some of the videos, the flight test videos, they actually have featured quite a few clips on 3D printed planes.
Yes, they have. Yeah, they have.
So they're pretty they're into both. Obviously they're mainly into and you can buy the filament from them, and most of the time, you can buy all of the parts for the electronics. Obviously, pretty much the parts that you're going to be using for 3D printed planes are also, the same parts that you would use for a foam board plane anyway. So good,
yeah. Let's see here.
That's it. I figured you might have questions on what do these things mean?
And that's good. Like a lot of people don't know. PLA is here a lot, and they forgot. Polylactic acid is a semi-organic molecule that's it's a plastic, but it's made from a plant base.
I believe so, isn't it? Is it? I know one of these is made out of the same stuff they make plastic bottles out of.
That's PTG.
Is it PTG?
Yeah. The plastic bottles are PTG. I was literally looking at a build log of one of the models, and I was like, because it was one of the models that's a reconnaissance ship, and the whole front of it is basically a frame and glass, right? Or at least the original was. And so I'm like, how the heck are they doing this? I was looking through, and they basically had, you take sheets of overhead sheets. And then for the curve part, because there's parts of it that are really heavily curved, I said, go get a plastic bottle. Cut it out of that. It's the same stuff. It's like, exactly. That's a good idea. So TPU is thermoplastic polyurethane. That's the one that's it's pretty flexible, but it's not a foaming.
Well, you can get a version of
foaming.
Yeah.
But
that's
it's like a rubberized. Well, actually, really, polyurethane is just it's a rubberized plastic, and it, depending on how you formulate it, it can be softer or harder, right?
Yeah,
And that's
I
what a lot
haven't.
of bushings are made from.
I must have. I've not got really into the chemistry of filaments, and I see now that
Yeah.
there's one company now producing, and maybe it's not the first, where you can make your own filament. So
Oh yeah, yeah.
yeah,
I bet.
yeah.
Let's see. Yeah, the polyurethane. I'm just shocks for some of the airplanes, full scale airplanes. All they are a certain hardness of
Mhm.
polyurethane, and they're in like a bunch of rubber discs that sit around the shaft, and they sit in the outer tube. So they're basically like these donuts that fit over top, and then they basically, when you land, they compress,
Oh, okay. Yeah.
and as they compress, they push out, and that helps with shock absorption.
Mm.
And so they're your shock absorbers, is what they are.
Yeah.
And you can make
Yeah.
them, like you can make them in your shop because it just
Mm.
literally mix polyurethane and pour it and wait.
Mhm. Oh, right.
You just test to make sure you got the right hardness.
Yeah.
ABS is the stuff that plastic pipe is made from.
Yep. Yep.
It's the
What's
exact
it?
same material.
Yeah, it's the like the drainage in your house is made from ABS, isn't it?
Yeah, yeah.
Yeah, the
Well, yeah, and
drain
ABS
pipe.
is right. ABS is the other material,
Yeah.
or ABS and what's PVC.
Mm.
but
Yeah,
yeah, a lot
PVC.
of the pipe is made out of ABS.
Mm.
STL, that's like a file type, and so
Mhm.
I think that's a standard tessellation language. I think is, or is it
Yeah,
the
like
triangle language?
yeah. That I mean
Is what the
that
files are made from.
yeah. Basically, it's just the geometry of the model. So it's a bunch of
Yep,
triangles, from what I
yep,
understand, and
yep,
so that's why when you load it into the slicer, you've got to add all of those parameters, to be able
yep.
to print that object in order to generate your G code.
Right. And G code stands for geometric code, which is
Mhm.
tells the printer what the head's got to go do
Yep.
very
Tell us that
specifically what how
yeah.
the printer's going to move and how things heat up and cool
Yeah.
down.
And it's the
So
same code that's, I mean, the code originated, I think, from CNC machines,
yeah,
yeah.
yeah. With
Um,
when just doing the needle cutter,
yep, same thing. The
it
G
uses
code,
a
yeah.
G code. Yeah,
Yeah.
and it's basically a positional code. It tells how much the motor has to move at X and Y, and then
Mm,
how much a different motor of
yeah.
some sort has to move it up or down.
Yeah, I mean, the firmware in the printer or the CNC machine
Mhm.
it basically interprets the G code into physically moving the head
Right.
of
Yeah.
the printer of the CNC machine. Yeah.
Hmm. Yeah, so I mean, it's no different than the only difference is instead of um, a rotary head or in the needle puncher, it's basically like a sewing machine. You know, instead of that kind of motion, they're doing the same thing but with a glue gun, a glorified glue gun. Right? I mean, the
Yeah.
filament is just a really long glue stick made of plastic,
Yeah.
and the
Mhm.
head of it is just this, thermal heater.
Yeah, I mean, it's
Obviously there's
yeah. Mm.
more, but so what's a
Yeah, I mean,
3MF?
that
What
was
is it used?
the 3MF is well, in the case like the bamboo or the orca, that's when you group all those plates together, and
Oh, right. Okay, yeah.
when you save it as a project file, okay, it will actually put a
Save it
3MF.
as a
But
3MF.
yeah,
Okay.
but I be careful with 3MF because it's meant to be at least from what I understand, it was meant to be like a universal length, a universal format. But take an example. If you take a 3MF file from that was designed that was created with a Prusa slicer, and you try to load it into Bamboo Studio, it will tell you that the only thing it extracted is the STL part. Okay, it doesn't leave all the others. But I mean, what I understand, it's an XML file, so it's actually what an interesting thing you can do. You can change the suffix to the file suffix to a zip, and you can actually view the file. So you can
Oh,
unzip
okay.
it, which is kind of interesting. I haven't tried it, but that's what I understood.
You're right.
And
Yeah, you can
it's
make a
all
copy
ASCII,
and try.
yeah, and it's actually an XML format. So, but
Cool.
there seem to be like very, it's almost like Splicer slicer specific, rather than being a universal tool. I think maybe the object was to become like a
or
universal
it may
format.
still be universal. It's just it may be universal in how it gets put together,
Yeah, maybe
but
the way it's implemented. Yeah, yeah.
because each printer, like the lines may be the same, like they may mean the same thing, but they don't correlate directly
Mm,
because Bamboo's got this extra thing, and
mm.
now it's like it kind of sets off the whole.
Well, I think it's fairly like you can add, from what I understand, with the little I understand from it, is that you can add extensions. Okay, so like for example, that's maybe what Bamboo decided to do. They decided to add extensions that would include the different plates. Okay,
Right,
which Bruce the Slicer didn't do.
right. So you
But
can't.
yeah. So I don't know. I don't know if in other slices, but yeah, you can't move it. Like the bottom line is you can't seem to move a 3MF file from one slicer, to another one. So
Yeah.
unfortunately, I thought because the nice thing about the 3MF file is that it does contain not just effectively the STL part of the object, but also all the printer settings. So
Hmm.
the temperatures and basically you should by loading a 3MF file and then clicking slice and then print, slice, it will generate your G code. So you don't have to go through you can make some modifications if you want to tinker with the settings, or you need to change some of the chat settings
Okay.
to suit your printer. But
Nice.
yeah, that's yeah.
Cool.
So
No, that
well,
that was
hopefully, yeah, yeah.
pretty thorough. And I again, the part of the reason if you made it this far, hey, a big thanks for listening all the way through.
Yeah.
Hopefully Richard was captivating you with the information he was telling you about what 3D printing in an airplane in today's printers and slicers means. Um, I feel like it really was just almost like a paradigm shift where suddenly you look at the old printers and kind of go, I don't, if I'm going to go forward printing a lot of PLA, I'm going to continue this. The options and the reliability that's available now just seems like, not that the old printers won't work and they're still not good. You can still use them. As a matter of fact, if you're interested, you could probably look around and see if somebody's getting rid of their old printer for pretty cheap, or even hand it to you and say, hey, I heard you were interested and I'm getting a new thing. Here's yours. Um, but they're just the new ones, the speed and the accuracy that they give you with that first layer being guaranteed almost.
Yeah,
And
they're very
and the
very good at the
and,
first
and
layer.
and the speed that they're able to lay down normal
Mm,
PLA and other substances
mm,
is seems to be just it really kind of opens up the door for certain projects. You're like, oh man, that'll take too long. It doesn't make any sense, or the finished product is such a good quality that honestly, a filler primer is probably all you need to get rid of layer lines if you wanted to use it for making molds. And I know a number of people do
mm.
that.
Yeah,
Um,
like injection molding is I
mhm.
mean it's good for making. I guess you need to use special materials for that, but
Well, even like I'm doing a lot of fiberglass stuff for the
mm.
airplane, but if I'm going to
Oh yeah,
make
mm,
if I'm going to make I want to make mold out an armrest, or when I'm looking at my dashboard, my control panel, and I've got all the doodads on the armrests and things like that. When I'm making like my throttle handle and my control
mm,
stick stuff, like I can buy them. I can buy them for an astronomical price, is what it feels like.
right,
Or I can consider, do I want to make one that fits good for me, that it fits
mm,
in the spot that I want for the airplane? Because unfortunately, by being an experimental and by being generally relatively low production, and none of that stuff ever got standardized. Not that it really needs to be. Um, most people kind of said, well, these seem to be the places it fits best, but it's almost like with your RC airplane. Like if you're going to do stuff to your RC airplane, you're going to make your RC airplane fit for you, right? It should
mm,
work for you. Well, they have a standard and you want to follow it. But when you want to do some custom stuff, that's like, hey, I want to build I want to build a new handle, right?
yeah,
Um, that those, and as a matter of fact, if you look at Ramy RC, most of his original models, he would 3D print. He would make a model of the airplane.
Mhm.
Then he would make a box and subtract the airplane,
Okay.
and then he would slice that up,
All right.
and then he would print out big blocks of mold, basically. They would prep the mold, and then he would do fiberglassing. And so his fuselages for the really large airplanes that he made, up until he went and started working with William Perry, I think, is the gentleman who has that giant. It's awesome. Anyway, that's not what this is about. But he used the 3D printing and PLA, and especially with the speed of these things, you can really get away with anything. If you've got a model, you can make a negative mold. You can make the female mold, and then because a lot of times the challenge of fiberglassing stuff is you need to make an original buck. You need to make it perfect. You need to make sure that it isn't that's been waxed and properly whatevered, and then you make you layer a bunch of fiberglass around that, and you make a mold and two halves of it. Right? It's like, well, we can go straight to the mold. With 3D printing, you can go straight to the mold.
Yep.
And then now you're basically producing parts
Mm-hmm.
at that point, which is, I think, what he decided he was going to start doing. And I think he had a lot of success with that. I think that's where the extra speed of the newer printers really comes in handy. Because if you're wanting to take a model, you can probably drop all the STLs in place and then make negatives. And if you wanted to make a fiberglass version of you know what I mean, of the 3D printed plane, it actually isn't that hard to do.
Well, the other thing with the newer printers is usually the build volume is now increased pretty dramatically. So the parts don't. I mean, typically with a like a 3D printed RC plane, you're printing. You have to print a lot of parts because your build volume is restricted.
Right. Is it limited about 8 inches or so? Right. 8 by 8
well,
by
yeah.
10
I mean, the bamboo one I have is 250 millimeters by 250 by 250.
Okay.
But their new one, the new one came out. I think it's like 350 by 350 by 350 or something.
Yeah,
like that.
I saw that the newer ones, and then the height seems to be even more.
Yeah.
Like, whoa.
Well, the other thing that they come out with is they got two extruders as well, so you can have multiple multiple filaments, and then you can actually even. Well, I think one of what's their promotional video. They print a bicycle helmet, a cyclist helmet.
Yeah.
And so it's got the TPU. It uses TPU as well as PLA, but it's printed as one thing, even though it's using two different types of material.
It goes back and forth with the different materials.
Well, yeah, I think So one filament is coming out like this. So basically, you. I mean, the way they say this is like a home manufacturing machine, so you can, print. I mean, it probably takes a while, but and then
I'm not sure. So and this is kind of a side story. Ultimately, we can talk about it later. But I ran into somebody who's basically had their business was 3D printing, and they had a series of the new Cobras or bamboo. I think he told me he has a bunch of everything really at this point. Yeah. But he's like the fact that they've got the ASL, the multiple spool loading,
AMS.
AMS, management systems, where you can have 16 different filaments loaded up, ready to go, and they all kind of feed to one machine that you can, if you make the model right, you can say, I want to print this silly panda. I want the hair to be TPU. I want this to be black, that to be white, those to be green, this to be whatever, and just print it. And it goes, and it'll go back and forth. And it may take a little bit longer, but with the speed of these, it's not as bad as it was.
I think this is what they ended up with 2 extruders on their newer model, because you like you said, you can have up to 16 filaments effectively, all going into the same extruder.
Head.
And the same print head. But the thing is, when you change from one filament to the other, you have to purge the old filament. Okay.
Right.
So
Right,
they
and
have
so you end
this.
up having a good bit of
Well, you
waste
have this.
doing that.
You have you have this white tower, and so for every time you change, you've got to like lose a bunch of
Wipe it
filament.
until you're out. Yeah.
Yeah, and then also the other thing is that's actually not only using filament, it's also using time. For the print.
Yeah.
By going to two extruders, that can be quite cut down the time quite a bit.
Yeah, because
And
you're
I
not
think
having you have not if
yeah,
you make it out of only two types of material or two colors,
mm,
you're limiting. You're not having to change it at all.
right.
Are you just
No,
going which
no.
head are you building
Yeah,
off?
yeah, exactly. And I think like the Prusa, I think that one of the new one of the Prusa, I think it's the Prusa XL. I think they have four heads, four tool
Hmm.
heads. So
That's crazy.
that's yeah.
That's
It's like
awesome.
yeah. But
They're kind of like, wait, things are possible now that it's not going to take all day to figure out if this works. I only need a couple hours. Like, wait a second, if it takes a couple hours to print this, adding an extra half hour to make sure that we just have a bunch of materials available all the time,
mm,
huh? Maybe that's suddenly worth it.
mhm,
Like where it's prohibitive before.
right,
Now with the increased speeds and the lower print times,
mm.
it's
Yeah, I
it's
mean,
interesting. To me, it's fascinating, and I'm excited to see where it takes our aircraft. Right, because to be able to build a scale model just with very little, honestly, to be frank, it's very little effort. So I'm not
mm,
having to craft it. Right, I'm not having to go in and make sure all the dials and bezels are just so or whatever. Like no, that's already been done. I just need
mm.
to make it. I just need to go fly it and have fun. And you're like, it's a little bit more work than that.
Yeah, oh yeah, it's a I mean, yeah, it's well, yeah,
Because I
like, I
mean,
mean,
yeah, like you
yeah.
said, like you had in that picture.
Mm.
Sorry.
I was gonna say, well, like you said earlier, yeah. Once you've printed it, I mean, the printing will take, I think that might have taken me a week or so, maybe to print it. I'm not printing 24 hours a day, but printing, quite a bit.
Yeah.
And but then once you've printed all the parts, then it's like, you just basically you can build it in a few hours.
Yeah. A couple hours. It's a simple
Yeah,
assembly.
yeah. So the assembly time is pretty, pretty. The only thing with 3D printed plane is if it does crash, it pretty much shatters. So
Yeah, that's it.
it's not as robust as it's not as forgiving as foam board. We can usually get away with dents, but if you don't really get dents with filament, you get cracks. And
Right. Yeah.
and so
Which some of them, when it's not a shattering kind of failure, you can
mhm.
literally just go get your glue and fix it.
Yeah,
But if it
unfortunately,
is shattered, you
yeah.
can just replace the piece.
Well,
Right.
well, usually, if you've got a separate wing, for example, if the wing is typically separate from the fuselage, which,
Hmm.
in most cases it is, your wing may be intact, but your fuselage needs to be rebuilt. But once you bought the files from the company, you can then just print another one. It's
Exactly.
not, yeah. And,
Right.
but no, I mean, it's nice. I tend to like switch. I'll have a period of time where I'm really into 3D printing planes, and then I want to rest from it because and then I'll go back to doing foam board planes and using the cutter and CNC cutter.
Right.
Um,
And you kind of fall back in love with the one, and then you
yeah,
kind of
and
get
then
while you get fed up with it, and you're kind of like, oh, I forgot about these over here, and you go,
yeah,
oh
and
man,
then
3D printing is pretty cool.
and then suddenly like Eclipse will come out with a new model, and you go,
Oh
oh,
yeah.
I've got to have that one.
Yeah, you keep
Yeah.
posting in the 3D forums about check out Eclipse, and they got this new model, and I'm like, oh man, that looks so good.
Yeah, I was interested because last Friday they announced their B-17. So like
Yeah,
I started to print Eric's B-17, the 83-inch
his
wingspan.
his is so detailed though.
Oh, it's much
And I
more
was,
detailed than Eclipse
I,
on. Yeah.
yeah, I was really impressed. I mean, I would urge you to go take a look if you hadn't already.
Mm-hmm.
But yeah. Well, look, I know we've taken a good bit of time
Yeah, we
tonight
have, yeah.
to talk about this, and I'm glad we did. I really appreciate you coming on
Oh yeah,
tonight,
no
Richard,
worries.
and
Yeah,
and talking. Um, Is there anything you want to point them to, or if they have any questions, where could they reach you?
Probably best places would be on the FT forum, I guess.
Mm-hmm.
On my Spitfire 76, same as the Discord server.
Okay, good. Yeah, you'll likely see Richard in our forums as well. You're always posting stuff.
Yeah, and one of these days I'll have a website that I mean, I already have the filamentflyer.com URL. I just need to put together the website.
Nice. Well, yeah, us too.
Yeah.
I mean, technically we've got a site, but we keep saying I'm gonna update it, and that's like we make a bunch of headway, and I think, okay, we're almost ready, and then something, life takes us sideways. That's usually what happens. Yeah. It's okay. Well, good. Richard, I again really appreciate your time tonight. I love talking to you about this stuff. I appreciate that you kind of keep everybody's mind focused, or continually coming back to seeing what more is possible with 3D printing as we go ahead. And again, if you go ahead, let me know when that starts. I'll make sure everybody here knows when you start.
Yeah. I mean, I think the first thing would I have preserved the YouTube channel and stuff, and I know it's a lot of work, to put together all these stuff, even though I do have a bit of time, but
it's easy, they say.
Yeah. Well, thanks for inviting me along. So, hopefully it was helpful.
Yeah, no, it definitely inspired me to get moving on 3D printing. Like, I've been wanting to have a model of any sort of the plane I'm going to build. I would love to have a couple of them. One, I can go fly and not worry if I crash. I can 3D print a new one, or I have got foam that I can just kind of hang as inspiration for when I'm out in the garage throwing a bunch of fiberglass around or whatever I'm doing. Trying to get that thing built. So yeah, it's good. Well, thank you so much. Again, we'll chat soon.
Mm-hmm. Okay.
All right. So I'm going to close it out. So I'm going to do my best Joe impression. As always, guys, thanks for tuning in and listening. If you have any questions or comments, you can reach out to Joe at Aviationrcnoob.com or at Matthew at Aviationrcnoob.com. You can go to our website at www.aviationrcnoob.com. Sorry, our emails were at gmail.com, right? No, Matthew at Aviationrcnoob. I did say that. Okay, I said it right.
You did say it right. Yeah,
I did say it right. Okay, we also have a YouTube channel. We're going to post this that we're talking about. We're gonna hopefully the recording of the audio, video came through, so you can see the presentation that Richard put together, and you get to see our wonderful faces talking back and forth. We're going to post that to our YouTube channel. I urge you to go back, and if you haven't listened to any of our conversations with Red Jensen or Richard or Al Bowers, the videos that we put together for that, or even talking to Leon from the Ultralight Workshop. I mean, I go back to those videos myself when I'm trying to remember, like, wait, how did those calculations work out? Or like, what's the new thing? The composition, the composites from Red I'm still looking at that. I go back through it as I'm trying to build my plan. I'm like, wait, what were the recommendations? So anyway, but so you can do that. You can reach out to either of us at aviationrcnoob@gmail.com, and then both Joe and I will get that. I don't think I have anything more to add. Richard, do you?
No, I don't think so. I think you covered most things.
Yeah, I think so too. All right. Well, we'll talk to you next time. Bye.
Okay, bye.
Somebody must have figured it out.
And
all of a sudden, lightweight print, because that was one of the other concerns that a lot of people had with lightweight PLA, was that they'd be done with the part, but it'd look like a mess. What? Hello? Can you hear me? We may have a technical glitch. Richard, can you hear me? Okay, that didn't work.
No, that just sort of changed the order or the order of
Yeah.
things.
Oh well. Logan Quinn, I can hear you. Just go to bed.